we're super excited to be back in Podium Mosaic again. And we're also live streaming on YouTube, and you can find the information also on our website. Before I go a bit more into the logistics of today, I would really, really like to thank our sponsors who stuck with us and showed us their support. They are, in no particular order, Kwanzaa, OpenBSD Amsterdam, Internet Society, NLNOG, Arista, NLNet Labs, Duocast, i3DNet, LoanApp, PowerDNS, SpeedIX, KPN, Solid Optics, M6, Juniper Networks, and RIPE NCC. A big thank you for making NLNOG Day possible. You have noticed that today is a little bit different than previous years. Of course, there was the health check at the entrance, and you've seen on the agenda that the breaks take longer. This is because we need the time to move around and to get seated downstairs. That's one of the other corona measures, is that we have seated lunches and coffee breaks. Face masks are optional. You can pick them up at the registration desk, not mandatory. But please also respect people who choose to wear them. There are two types of lanyards. The people who wear white might choose to shake hands. The people who wear blue will not shake hands or have other physical contact. So please have your lanyard also visible. Don't put your hoodie over it, so people know what your preference is. Yeah, we really tried to keep this event safe and fun for everyone. So please help us by respecting the rules that apply. At NLNOG, we have a code of conduct, and we all take pride in the friendly atmosphere that we are known to have. If there's anything that makes you uncomfortable, please see me or Thomas, so we can act and resolve it. Be your friendly self today, also if you're watching online and participating remote. Then, there is something else that's different today. We had a change in the NLNOG crew this year. Job Snijders decided to leave the NLNOG board after 10 years. He is one of the founders of the Stichting NLNOG, and he was the driving force behind all of our events. He attracted most of our sponsors, our speakers, the international contacts, and worked hard on creating and maintaining the tools. Now, Job, out of the NLNOG board, is a huge loss for all of us. And I miss the lively discussions that we had in the lead up to events and the fun we had with organizing them a lot. Yeah, he did amazing work for NLNOG, and I think I speak on behalf of the entire crew. I want to thank him for everything he did at NLNOG. So thanks, Job. Then we had big clocks to fill. And we asked on the list for volunteers to help us out for the NLNOG board. And I am very happy that Teun Vink and Niels Bakker, who's downstairs checking QR codes, stepped up. Both of them have been active in NLNOG for over 2 decades. And they already picked a lot of work in the lead up to the event. So please help me welcome Teun and Niels Bakker. If you've seen the agenda on the website, you see that we have a wide variety of topics, from hardcore tech how-tos to interesting stories, and we're also not shy of the more sensitive topics, like how we're mentally doing after 18 months. I want to thank all the speakers for their time and effort to make NLNOG Day an interesting event. One more last remark, that's for the remote remote participants. We welcome all your questions on the IRC channel, hashtag NLNOG. but also on the YouTube chat. If you want to have a question relayed to one of the speakers, please mark that clearly with a Q before your question, and then one of us will go to the mic for you to ask the question. Now, sit back, relax, and I'll hand it over to Niels to introduce our first speaker to you.
Thank you very much, Nathalie. And our first speaker will get a little more time than expected, because we are already 10 minutes ahead of schedule, so this is great. Our first speaker of the day is somebody who is here in person. There will be a couple of speakers who will present remotely, so we will all be watching the big screen. But Frank is here, and you may not know him in person, but he may have been sending you email. And if he did, then you probably have naughty customers. Because during the day, he is the CISO of Schuberg Philis. But at night, he turns into a security researcher who tries to find open ports, maybe closed ports, but not closed enough, security holes, and then he emails you about them. Please give a warm welcome to Frank Bredijk from DIVD.
Thank you. Thank you very much for that introduction. And obviously, I have my own introduction slides as well. So hi, we're AS50559. Currently a bit of empty space on the internet, but yeah, my name is Frank Bredijk. I'm the head of CSERT. I'm also a researcher. 2 years ago, I initiated something called het Nederlands Security Meldpunt, because I was unhappy about how we exchange security information in the Netherlands. And that little joke turned into what's now called the DIVD CSERT, because I joined forces with DIVD. So if you want to reach me in that persona, here's how to. Others may know me through this AS, which is obviously Atom 86 and not Schuberg Philis, but Schuberg Philis is the master company of, the mother company of Atom 86. And there I'm the CISO, but I'm here to talk to you about DIVD. So just out of curiosity, who knew about us? Okay, that should have been more, so it's good that I'm here. There was this little ransomware thingy with a company called Kaseya. They make software used by managed services company, like Schuberg Philis, but lucky for me, not Schuberg Philis. And they had a security problem. There was a 0-day vulnerability in their software, and it turned out that, well, actually there was more than one 0-day vulnerability in their software. And it turned out that through their software, you could take it over. And then the handy thing with remote system administration tooling is that you can administrate a lot of other tooling. So, for instance, Co-op in Sweden had to close 400 of their 800 supermarkets. There were other companies that were in a lot of trouble. A lot of people had to work that weekend, which was especially disappointed if you were American, because they timed the attack to coincide with Independence Day. 4th of July. And we were talking to Kaseya previously. We nearly prevented it. We managed to prevent some damage by telling them about the vulnerabilities. They were already working on a patch. And if they hadn't been working on a patch, and if we hadn't been scanning the internet to find these servers, then cleaning up the mess would have taken even longer. But you also may know us from our chairman, who managed to obtain the password of Donald Trump twice. Our involvement in the Citrix crisis, which was the little crisis before we all went home to face Corona, and other stuff. So DIVD, Dutch Institute for Vulnerability Disclosure. Dutch, does that mean we're only doing things for the Netherlands? No, it's more about our mentality. Open, honest, collaborative, for free, run by a bunch of volunteers on a budget of a shoestring and a packet of gum, but with an international reach, because we think that really national boundaries are pointless on the internet. They exist, but they don't exist. We're an institute. In 2 years, we've grown from 4 people with a wild idea to a fully fledged organization of over 60 people, with a board, a CISO, a privacy officer, an advisory board consisting of people who are quite known in this world, and 3 branches: research, a CSIRT, and an academy, which opened recently, all underlined by a code of conduct. And that code of conduct is important because in my day job, I have a word of advice for colleagues who inadvertently think it's a good idea to scan others. It's like, well, when you do that, I have 3 things that I think are important: permission, permission, and permission. And then lesson 2 is a recap. Did I remind you that I find permission important? But as the IVD, we scan everybody, and we're not asking for permission. And we're not just scanning, we're actually trying to find vulnerabilities. And sometimes by finding vulnerabilities, you have to exploit them in a way that is safe to do. And that's a dilemma. We're literally coloring, to use a Dutch metaphor, we're coloring on and sometimes over the edges of what's really allowed by law. But we do it with good intentions, and we try to keep it proportional. So, for instance, DDoS vulnerabilities are very hard for you, because I think I would have a lot of issues with, well, quite a big part of this audience if I took people's network down while scanning. So code of conduct, really important to us. And then we deal with vulnerabilities. And what kind of vulnerabilities do we do? Well, we've got 3 kinds of cases. We deal with critical vulnerabilities, so things where is the internet on fire goes, yes. We deal with data leaks and victim notification there, and we deal with 0 days. So to zoom in on critical vulnerabilities, well, we had the case with the Citrix crisis. And in the Citrix crisis, we had Citrix NetScaler, which is a product to keep people secure, to facilitate secure access to the internet, or to company networks, not to the internet. So it's a way to get, well, to do remote working, what we've all been doing for a year and a half. And it turned out it contained a nasty flaw. If you had that product to secure in the network, you were actually not that secure. We had a minister who was telling everybody that if you hadn't patched for this vulnerability, you were a pancake. No, sorry, you were an oliebol, an oily ball, a Dutch traditional New Year's snack. And we actually had a number of researchers who had sent a list with all the vulnerable servers to the National Cybersecurity Center. So how can you call people oliebollen on the one hand, and on the other hand, have a list of those people and not tell them that they're actually vulnerable? Well, there's a whole political landscape behind that. But in the end, the Citrix resulted in a physical effect. We had genuine Citrix files, Citrix traffic jams on the road. Turns out that if everybody who normally works at home goes to the office, the Dutch road system can't handle it. Pulse Secure, another case that we ran, had to do with Pulse Secure VPN appliances. And again, it turned out that those things weren't as secure. And there's a theme emerging at the moment. And then, the most current case, proxy logon, and it's followed by proxy command, proxy token, proxy oracle, basically a new attack surface on Exchange servers. It turns out if you haven't patched your Exchange server since July, what are you doing here? You should go home and do it right now. Well, you should go to your office and do it now, or log in. Well, watch this talk and then log in and patch your Exchange server. Because it's an insecure product. What do we do in these cases? We scan the internet, soon from our own AS. Right now, we beg, steal, and borrow VMs from people who provide them to us. And we scan the internet trying to find vulnerable systems and inform the system owners. And then we do victim notification. Victim notification of cases where we find credential dumps. We have a lot of researchers, security researchers, who are part of DIVD, and every now and then they find something. And it turns out that being a cybersecurity expert is not a guarantee that your system is secure, but being a cyber criminal is also not a guarantee that your own systems are secure. So sometimes people have a command and control server, and then they have an Elasticsearch database with all their victims in there that they're trying to exploit or have exploited and extracted their data. And they haven't secured that. Or they leave their log files in open directories, and you can get, from those log files, you can get whatever they stole. So what we tried to do in case of the warehouse bot, for instance, was actually notify these people. And it gets you very interesting conversations. Conversations where people, you send them an email, hey, listen, we found this on the internet for you. This is a list of your passwords. By the way, for safety, we always put asterisks, so we mask parts of the password. And the reaction is, bleep, you scammer. No, I'm not the one trying to scam you. I'm trying to tell you that you've been scammed and you have this problem. Sometimes we actually manage to convince them. Sometimes we don't manage them to convince them. If we do convince them, then it's like, oh, what should I do? Well, we put some advice in the emails, luckily. Sometimes you send out an email saying, hey, we found this compromised data in your email account, and it turns out that one of the things compromises their email account. So as a nice thank you, you get some malware from the scammers trying to infect you right back. Sometimes you hear nothing. Sometimes people get upset. All 7 stages of grief come by. Yeah, and we've had 3 cases now. So we've notified people about Mirai devices in their network that have been compromised. Mirai compromising IoT technology like DVRs, digital video recorders, and other stuff that are still available across Telnet with default credentials. There's so many things wrong in that sentence. Telegram, we're in Telegram groups where things get shared. Yeah, and a lot of people find it very difficult, especially public agencies find it very difficult to deal with this kind of information because there's a huge privacy aspect. So mailing everybody the whole database of credentials is not something we try to do. But divvying it up and working with other people to share this data in small volumes is something we do. Yeah, and then the juicy part, the zero-day vulnerabilities. A zero-day vulnerability is a vulnerability that you know about, but was patched 0 or less days ago. So basically, there is no patch for it yet. So far, we've got 3 cases running where we found these things. Vembu BDR, which is a backup solution, which is really nice if you can compromise a backup solution if you're an evil hacker. Because backup solutions typically back things up that are important to an organization. So you know that if it's backed up, if it's reachable from the backup appliance, yeah, it must be good. It must be worth something. Kaseya VSA, Virtual System Administrator, I talked about that before. And Kaseya Unitrends, which is the backup solution built by Kaseya, which is similar to Vembu. So in these cases, our researchers, in their spare time, sitting on the couch next to their wife while watching Netflix or something, were playing around with this software and found vulnerabilities in them. And that's bad news. And then I come to the disclosure process. And the disclosure process for us is what it's all about. Because our mission is to report vulnerabilities we find in the digital systems to those people who are in a position to fix them. Yeah, and then in the Netherlands we have something that's called een landelijk dekkend stelsel, air quotes mine, but isn't actually that fully covering. It doesn't cover everything that we do. So yeah, we have to rely on for instance, the Whois database, which is, how should I put it politely? It could be better. But we do need your help there to allow our scans to go through. So if you see a scan from us, yes, obviously the good thing would be to, one of the things you could do was to contact abuse@divd.nl. This is not abuse, this is what we do. The other thing you could do is allow the scan through, and if you get an email from us, please forward it. We often don't know who's behind an IP address. You have a contract with these people, hopefully. So hopefully you do know who's responsible for this bit of network space, and hopefully we can, yeah, we can get to you and get you some, get some help, get these people informed, and get them to fix their vulnerabilities so the internet becomes a little bit of a safer place. Critical vulnerabilities in the Netherlands, we work with partners as well, trusted information sharing partners. Organizations like NBIP, Connect to Trust, the NCSC, DTC, CSIRT, DSP, the Anti-Abuse Network. Yeah, just about anybody that wants to work with us and can actually get us in contact with people sooner. Via the network provider, sometimes we can go directly. I mean, things sometimes have an SSL certificate or a TLS certificate that actually says, hey, this belongs to this organization. Well, in that case, we don't need to bother you, we'll go directly to them. But finding out who's responsible for fixing systems is sometimes an issue. Because if you send an email to info@Mozaïektheater, will the person who reads the info address actually understands us? And internationally, we often go through the network provider or go directly. In case of victim notification, we try to approach the victims. So if it's a nice combination of an email address and a password, well, we'll email that email address. We try to report it to the site operator. So if it says the Facebook password of this person is that, then we try to report it to Facebook. And we're trying to work together with the No More Leaks initiative. But yeah, that's still being formed. Yeah, and with 0 days, we try to stay within the coordinated vulnerability guidelines, which roughly says 90 days after, gives the vendor 90 days to fix a vulnerability, and then some sort of disclosure happens. So we work with the vendors, we try to be nice, we try not to be too aggressive. We take the 90 days as a guideline, because we think it's better to breach news about vulnerabilities if there's something you can do against them as well. Otherwise, it's like, this is your captain speaking, the left wing is not on fire. Yeah, and afterwards it just becomes a critical vulnerability, meaning scanning the internet, trying to identify the vulnerable systems and going through to the system owners or through the network owners. And like with Kaseya, sometimes our hand is forced and an investigation into a 0 day that nobody knew about turns into an investigation and a help and an aid operation in the biggest ransomware attack ever recorded. So important, 3 parts: research, we have researchers, the CSIRT and the Academy. Research is there really to find vulnerabilities, to define scanning methodology. Scanning the entire internet is not easy, not to mention IPv6, which we still haven't solved. So anybody with good creative ideas on what we can do there, yeah, come see me. Finding 0 day vulnerabilities. Yeah, so I get an advice, donate a server to pool.ntp.org. It will get you a good enumeration of what IPv6 space is in use. And we'll take that tip. I think it's one of the servers that's going to go into our AS then. CSERT, it's about triage, is something worth going through to do an investigation on, because we do this in our spare time besides day jobs, and we're security people, so we're not searching for things to do. We've got enough to do already. Publication on our website, csert.divd, managing the .nl, managing vendor relationships, and reporting out the vulnerabilities. And then the academy, Heroes Don't Scale. So we're trying to give some guidance to the younger people out there. I guess I'm one of the old school hackers that's around there, but we got plenty of young people around who want to learn. And we want to encourage them to learn, but we also want to encourage them to do the right thing and not end up with a criminal record or a jail sentence or on the wrong side, because I think the dark side has enough people already. So that was the plenary part of what I was about to talk. So if you've got any questions that you don't want to ask here, then this is a way to do it. But yeah, let's open up the floor.
Thank you, Frank. Now we have more than plenty of time to answer some questions. Just to be sure, we do appreciate the comment from the room just now, but for the benefit of our online viewers, please go to a microphone if you have something to say. Then next time everybody can hear it. I guess there was one question from IRC. There is also something with the YouTube stream. It is unfortunately not possible to place comments on the YouTube stream because apparently as soon as you start streaming, you cannot open the comment section anymore. So we had to do that before, or we need to stop streaming. I don't know, whatever.
Or
you tell me.
Or open 2 browser windows.
Go to IRC for your questions. I think we'll go to the room questions first. And if the light isn't failing me, this is Jan on the microphone, back to his old habit. Thank you very much having you back, Jan. It's great to see you again. What is your question?
Hello, Jan George from 6Connect. Thank you for this welcome. I think you're doing a really, really good job. Thank you for doing it. But what I saw in your presentation was just IPv4 addresses. Are you also doing stuff on IPv6? Are you scanning on IPv6? And if you do, how do you approach the scanning? Thank you.
Yeah, so IPv6 at the moment, we're not. At the moment, we're not, unless we use open source intelligence as well, things like Shodan, Binary Edge. So if we get IPv6 addresses from there, and we happen to be on a VM where IPv6 works, which isn't always the case with the things we right now beg, steal, and borrow. We're building our own infrastructure where we should have IPv6 connectivity as well. Then we're scanning that. Yeah, the time required to do a blanket IPv6 scan is astronomical. So one of the problems to tackle is how to identify the live sections of IPv6 versus the dead space that is in there that you're just wasting time. And the honest answer is not right now, not really. And yeah, we're open to collaboration and ideas on that. And the pool server, the NTP server is a good one.
We have another question from the room.
Hi, my name's Carl. I represent no one but myself. But I have a question with trolling online, and especially political trolling being a national policy in some places. Do you have a problem with bad actors trolling potential little targets, really, to soften them up, spamming them with these sort of white hat notices, maybe even pretending to be you, spoofing you, in order to soften them up for an attack later on, because then they'll just ignore it?
Yeah, well, there's no accounting for what a criminal does. Right now, it's not that much of a problem, but supply chain attacks are a problem. So if you look at, for instance, what happened with SolarWinds, where bad actors managed to introduce a vulnerability or a backdoor into a patch, that obviously is an issue. Unfortunately, it's one that we have to deal with. If we're successful enough, sure, somebody's bound to use us in a phishing campaign, saying you've got a critical vulnerability, click here to patch it. Yeah, we try not to, we do include links because people want to know information. Our website is completely static, so if you ever get a link from us that requires you to fill in any data, don't.
I think that is sage advice. There was a question on IRC as well, and it's also one that came up a little bit during the coffee we had together this morning. Now, you are here, you are Frank, you are the IVD, you have presented, and you tell us here, you tell the whole room, you are a good guy. And we should trust the scans that you do, and you are allowed to do scans. I think many people in this room would tend to agree with that and would allow you to do that. There would also be people who would ask, who are you? Why should you be allowing, or should you be doing scans? Why should you be allowed to do scans on my customers? And I guess the question is, what gives you the let's say, the legal power to be able to do this?
Nobody and none. We're doing this because we think it's the right thing to do. Legal power, it's yeah. So luckily we live in the Netherlands, and the Netherlands has computer laws that say that it's only a crime if your intention. I mean, within boundaries, but scanning in the Netherlands within the guidelines for responsible disclosure or coordinated vulnerability disclosure, as more politically correct people like to call it. It's okay if your intention is not to breach the systems. Luckily, we're in the Netherlands, and our public attorneys have a lenient opinion. If we were the EIVD or the UK IVD or the US Institute for Vulnerability Disclosure, it would be a lot harder legally for us to do our work, because their opinion of what we do is what we're doing is computer crime. So the intention, but if I take the Dutch approach, and I'm with the Dutch Institute for Vulnerability Disclosure, it's really about proportionality and subsidiarity. So a port scan happens, and is a port scan really a hacking attempt? Well, if what we're trying to do is to warn people about critical vulnerabilities that pose a danger to us, then a port scan should be okay. Now, sometimes to identify a vulnerability, you have to do an exploit. So obviously not okay is DDoSing an ISP or DDoSing a system to prove that it's got a DDoS vulnerability, because then you're causing damage. Obviously not okay is stealing data. So we have a constant battle where we're trying to keep, a constant tension where we're trying to keep what we do limited enough, make sure it's harmless enough so that the cure doesn't become worse than the actual problem.
Yeah. All right. I guess we have another question from the room. That's Arjen there.
Yeah. I have a question about some colleagues of yours, I guess. Just the other day we got emails from Netcraft that are apparently hired by de Stichting Internet Domeinregistratie Nederland, SIDN, to do also scanning on vulnerabilities. And I was wondering if you would know about that and what you think of it, and if you work together.
So you're telling me something new. So I can't comment on it. What I can say is that I mean, I do this in my spare time. A lot of people do it in their spare time. And although it's rewarding and in a sense, well, fun is maybe the wrong word, but exhilarating to be in a crisis like Kaseya, yeah, that's all we get in return. Mm-hmm. And in the end, the model we have right now might not be sustainable. So hiring somebody and funding and paying somebody to do this on a structural basis might be a good idea. If that has to take the form of SIDN and a commercial party, I don't know, can't comment on that right now. Okay. But I think if we want a structural solution, we shouldn't be relying on volunteers, even though we're trying to do the best job we can.
Okay, thanks.
I guess there's a question from IRC.
Yes, there is. Actually, two questions, both from Jeroen. The first one is, what is the problem you're trying to solve?
The internet's broken.
Okay, yeah. That's
Again, no, the problem we're trying to solve is that I think if we want the internet to survive and be useful, we need to keep it secure. And right now there's a lot of systems out there that aren't as secure as they can be. We did scans for back for proxy login, the Exchange vulnerability. We did scans on the day the patches were released, and you find 40,000 systems, 40,000 IP addresses online with Exchange servers that can be taken over, that criminals can install whatever they want on there. That's not good. That means that the internet becomes a little bit insecure. And then 2 weeks down the line, that number decreased from 40,000 to 30,000 vulnerable systems. That's too slow. So ultimately, if everybody took their responsibility and said that, you know what, the minute I have a vulnerability, I patch it, we wouldn't have to do what we did. Well, we're still the research on 0 days, hygiene. So there's quite a bit of problems in this space, but we're trying to, yeah, it's a bit asking the firefighters, what problem are you trying to solve? The problem is fires.
I think the additional question is, in what way are you different from other parties doing scans on the internet? Because there are numerous people doing scans at this moment.
Yeah, so we think that one of the differences between us and, for instance, Shadow Server is we're trying to go beyond just keep emailing problems, but we're trying to hand people solutions as well. So this is what you need to do to fix your problem. We're trying to answer questions. Why do we think you have this problem? If you ask us, we will tell you. The other thing is we don't think this should be either opt-in or opt-out. If you're on the internet, the minute you put a system on the internet, you took on the at least moral obligation to keep that system secure. And that means if it isn't secure, you need to know about it. And if your attitude towards that is, I don't want to know, yeah, by opting out of our notifications, yeah, sorry, there is no opt-out button.
Okay.
Was there one more short question?
Yeah, the second question was, how do you deal with honeypots? Because when scanning, you obviously run into honeypots run by people.
Yeah, so right now it's just reporting. If your honeypot is really good, we can't see the difference. And for people operating large honeypots, as soon as we've got our own infrastructure, then yeah, we can also work on a signal where we say, okay, we've got another scan starting, or yeah, filter us out on that way.
That sounds great. I think that's it for the DIVD presentation. Thanks again, Frank. Melchior has a gift for you. And now I need to do a little dance here, so enjoy. It starts with finding the next presentation. It's this one. We go to full screen, and then part of the dance is also, that we didn't invent this. It wasn't opened yet. Thank you very much, my lovely assistant.
How many engineers? How many engineers does it take to clean a keypad? So, our next speaker will be Martin. You may know him. He's been doing a lot of things for the NLNOG ring for the last 10 years, I think. You were there from the start, yeah. And we realized we never really had a good presentation on what the ring does. We did a presentation on one of the events on how it's built and how it's managed, but what can you actually do with the ring? So that's one of the things Martin will be presenting on now. So please take it away, Martin.
Yeah, so before I start, who here is participating in the ring? Oh, that's like 40 people. And who's been here with us from day one? One or two? Nice. So I want to start with the origin story, basically. So what happened end of 2010 is there was a network engineer with a problem. He was seeing some trace routes die, he was seeing packet loss, and he couldn't really pinpoint what was going on. Some destinations were reachable, some destinations were unreachable, not always at the same time, and the trace routes would stop sometimes in one place, sometimes in another place. So it was all very confusing and he couldn't figure it out. So he joined the NLNOG IRC channel, which you are all on or should be on. And he started asking people for trace routes and pings from their point of view. So he could only do his trace routes from his network, and he wanted to see the other side. So he asks around on IRC, and he gets pastes, and he gets emails with trace routes and pings and everything. And he goes on debugging and debugging, and he comes back on the IRC channel, asks for more trace routes, and this goes on and on for weeks, literally. And eventually, he did find his problem. It was located around a large internet exchange here in Amsterdam. But the point of the story is that people got really fed up with him continuously asking for data. And so in this discussion, somebody comes up with the idea, hey, what if we all spin up a VM or a physical server in our own network, and each of us gives everybody else access to that server so that you can get your own data and run your own debugging from my network, and I don't have to be in the middle and pass on the data that you need all the time. So that was actually pretty easy to set up. It took a very short time before some people set up servers. Then with a group of 4 volunteers, Peter van Dijk, Job Snijders, Edwin Hermans, and myself, we spent some time around Christmas 2010 mostly drinking the wine collection of Job's flatmate at the time, but also coding up some infrastructure to manage this stuff. And then in the beginning of January, the NLNOG ring was born with this lovely email to the NLNOG mailing list. So how this started out was with 10 participants, also 10 ring nodes. Most of them at the time were physical servers, because not everybody had a VM platform in their network yet. This is a bit different these days. We also realized immediately that this could grow pretty big. So we configured a Puppet server to do configuration management and to automatically deploy configuration SSH keys of the different users etc., on all the different ring nodes, so that we could manage the whole thing from a central place. Some of the early participants started working on tooling. We got the first tools, ring ping and ring trace, which I will tell more about later. They can be used to do some troubleshooting from different vantage points. And we had an IRC channel, hashtag ring on IRCnet, and we set up a mailing list. So the first year went pretty well. We started off only with participants in the Netherlands, but after 6 months or so, we gave a presentation at one of the RIDE meetings, and we started opening up for international organizations as well. So a year later, around 2012, we had about 100 participating organizations and the same number of ring nodes. And that's when we started with the first problems in the scalability of our management infrastructure. The Puppet server was running on a small VM provided by InTouch, and that was nearing its limitations. So we set up a fundraiser to get some money to buy our own infrastructure for this project. The goal was to get enough in for 2 physical servers in 2 data centers, and it was actually very, very successful. So we ended up with 4 physical servers that people donated, including co-locations, and enough money to buy a 5th one and host it. So that gave us plenty of capacity to build our management infrastructure for the project. And these were all the companies that helped us with that. So the years after that, once we had our infrastructure in place, we started focusing more on tooling. We added a looking glass, a BGP looking glass, which currently has around 120 active peers. And it also does RPKI validation, so that's another useful tool to check your ROAS if you want to. We added ring curl, which is a distributed version of the powerful curl library that you can use to debug CDN troubles from various different vantage points. And several participants wrote ring SQA and an accompanying SQA collector. Ring SQA is a tool that runs on every single ring node, and it pings and traces every other ring node. And then if it sees, suddenly sees problems reaching several ring nodes at the same time, then it can notify you via email or via Slack that there is a problem somewhere, probably with your network or somewhere else on the internet. And the SQA collector collects all the data from the different SQA instances on all the ring nodes, and it tries to correlate things. So it tries to correlate events that happen all over the internet and tries to see if there are certain ASNs in the path that are broken from multiple ring nodes. So you can identify outages in large transit providers, for example. In 2016, we ran into scalability problems again. The ring had grown to about 400 nodes, and again, we were having issues with our central Puppet server. It basically couldn't handle the load anymore of 400 nodes coming by a couple of times per hour to get a configuration and apply it. So we decided to move to a different model. We moved to Ansible in pool mode. In short, this means that we keep our entire configuration in a GitHub repository, and every hour Ansible comes by, does a Git pull, and runs locally on the ring node itself. So there's no longer a central server that manages everything. Every node runs its own Ansible and applies its own configuration, and that way we can scale further. More details on this architecture and on the whole migration can be found on the link at the bottom, the presentation I did in 2017 on this topic. This move to Ansible also allowed us to put in some automation based on the successes of the Ansible run. We were starting to mark nodes inactive that did not have a proper Ansible run and thus were broken. With 400 nodes in the system, it happens a lot that some nodes are broken for whatever reason. And having them not be included in tools like ring ping makes it much better to work with the ring. So we added that. And in the years after, we mainly saw a lot of growth until 2019, where we reached the milestone of 500 active nodes. As you can see, we are all over the world. We are currently with 592 active nodes spread over 55 countries on all continents, except Antarctica. So if you know someone with an AS in Antarctica, tell me. Also in 2019, we added more monitoring. You would think that a ring node is a simple VM with an IP address and a bit of software installed. How much can go wrong with that? Well, a lot of things can go wrong with that. NTP can die, DNS can die, IP gateways can disappear, you name it. So we implemented some more detailed monitoring to keep checks on that and to email people that have broken configurations. And one of the main points here that we find is broken IPv6. Now, for Jan, we did our part in fostering IPv6 deployment by making it mandatory to have an IPv6 address on a ring node. IPv4 is optional, but IPv6 is mandatory. Nevertheless, we find a lot of cases where IPv6 connectivity on a ring node is broken, but IPv4 still works, but never the other way around. So we never have cases where IPv4 doesn't work and IPv6 works. So sadly, after 10 years, IPv6 is still a second-class citizen also on the ring. Then finally, 2020, we used the Corona lockdown period and all the spare time that gave us to build a nice new website. Our original website was on WordPress, which is way too bulky for the purpose that we have, and it was a lot of work to maintain as well. So we moved to Hugo, which is a framework to generate web pages, static HTML pages from Markdown files. So now our website is simply a bunch of text files in a Git repository and a small script that's run by Ansible to deploy it on our web server. So over the years, we've had many users telling us that they are happy with the ring. We get these emails from time to time telling people how they're using the ring. And that ranges from debugging network problems to CDN issues, but also application issues like troubleshooting mail servers from different parts in the world. So it really helps us to keep going and to put effort in this project to see that so many people are actually using it. We're also mentioned in several research papers on network detours and routing overlays. So that's also cool that the academic world has also discovered our tooling. And then for this occasion of a 10 years ring, we made a little demo. So I'm going to see if that works. Oh no, a security warning.
Ik denk dat de wifi uitstaat.
Uh-oh.
Yeah, what shall we choose?
Gasten wifi?
NLNOG Day, I would say.
Where is it? Oh, there. Insecure?
Insecure, why
Insecure,
not?
yeah.
There's no password. It's easier. It's always better, right?
Let's see if this works. Not really. So yeah, perfect. So what do we need for using the ring is we need a key, an SSH key that everybody supplies when applying to the ring in the application form. And you need a working SSH agent. So we're trying this out now, and we're seeing that our ring ping fails. So we first need to set up our SSH agent. So we start the SSH agent, and we add our SSH key to it. Bum, bum, bum. I'm a slow typer. We can see that the agent is loaded. And now we should be able to log in on our ring node, and we pass the agent to the ring node with the SSH-A flag. We have our agent, and we check if we can now hop onto other ring nodes, in this case FreedomNet 01. And that works. So now we should be able to use some of the tools that we have available. And the first tool we'll try is ring ping. We're going to try to ping the NLNOG ring website from 20 different nodes spread all around the world and see if that works. Takes a bit of time. And voila, our website is reachable from everywhere. Another useful tool that we have is ring trace, written by Teun over here. Ring trace allows you, it's similar to ring ping. It allows you to do distributed things. In this particular case, a trace route. You can do trace routes from different ring nodes, choose which ring nodes, and it will display the trace routes visually. So what we're going to try now is ping a trace from 10 different ring nodes to to the ring.nlnog website. And we're using the -A flag. That means that we're going to see the different ASNs in the path instead of different router hops. So that makes the picture a bit cleaner. And now we can display the results in different output formats. We can store them in pastebin, or we can create pictures. The default is a JPEG file, and that you can use in your presentations, etc., if you want. So our trace completed. So now we copy the JPEG file to our local workstation, and we open it. And we have a pretty picture of a trace route. So we see at the bottom the PC Extreme AS. That is the location of our ring.nlnog web server. And we can identify, in the middle, we can identify transit ASNs and things like internet exchanges. We identify internet exchanges based on the IP addresses that we see in the traces. The most powerful tool we have is ring all, and this allows you to run arbitrary commands from different ring nodes. In this case, I'm doing a dig, I'm doing a DNS lookup for the IPv6 address of the NLNOG website. And I want to see if it looks the same from everywhere in the world. So if we get the same DNS response everywhere. And that is the case. So ring all is very powerful. You can do, you can basically run any command or script that you have, that you would like. But it might be that you want to do extra things. And for that, we have an API that you can use. So these are the available endpoints that we have. So for example, if I want to get the information of ring node Amazon 01, one of the ring nodes provided by Amazon, I use this endpoint, and I get all the information about that node, such as geolocation, IP addresses, the current status, is it reachable over IPv4, is it reachable over IPv6? So I can use that in my scripts to do some things with. The second call I just did was based on the participant ID. I see which nodes Amazon has, and that's 23 of them all over the world, basically. So that's a short demo of what you can do with it. More information and other tools are on our website, ring.nlnog.net. And if you have any questions, you can also send us an email. And now I'll go back to my slides. So to wrap this up, I want to give a huge thank you to all the participants, all 496 at the moment of them, for supplying VMs and servers to make this project possible. Also a huge thank you to the over 50 people that contributed code in our Ansible and other repositories. And of course, the current providers of VM infrastructure and co-location to keep all of this running. Lastly, of course, our website, and on the GitHub link in the middle, you can find our complete code that we use to manage our infrastructure. So if you want to play with Ansible yourself and you don't know where to start, we have some good examples of how to do things. And at the bottom, of course, if you have any more questions after this, you can email us. Thank you.
So, thanks, Martin. I see that we do have a question there.
Hello, I'm Andre from RipenCC. I would like to ask how you deal with abuse and how you manage, well, what is abused and what is not, because it's very, not very clear what is considered to be good to do on an NLNOG ring and what is behind the line. And maybe somebody has line in different place.
Well, in principle, the ring is meant to do short-term troubleshooting. It's not meant to do continuous heavy load measurements all the time, because if everybody would do that, we would run out of capacity on the ring nodes at a certain point. That's also why we have ring SQA, which does trace routes for you, so that not everybody has to do that themselves with their own script. As of abuse, even with 400 organizations, it is still a manageably sized community. So we have not encountered many cases of abuse. We've had one incident where someone found it a good idea to test their DDoS mitigation center from the ring, which we quickly discovered, and this participant then was terminated immediately for a few years after that, they came back begging, and we let them in again, and they behaved. We also recommend people to rate limit the traffic from their ring node because the purpose is debugging and the purpose is not testing the bandwidth of your servers.
Thank you.
Any other questions? I don't think so. Well, thanks a lot, Martin.
Dankjewel. Je kan ook als je wil intro vast doen. Dat is voor de volgende. Zo. Ik kan deze wel even gebruiken. And with that, it is time for our final presentation before lunch. And I would want to welcome Arjen Vijn and Reinoud from Leven, who will be talking about how to start a new ISP as the successor of well-known Access for All. The stage is yours.
Thank you. I'm Reinoud.
I'm Arjen.
I'm Arjen. We're working at Freedom Internet. I assume most of you have heard the name a little bit. And like you said, people see us as the next phase in Access for All. Most of the people at Freedom have actually worked at Access for All. And I will tell a little bit about what happened and how we are doing this. But we try to do this in a dual presentation.
We did not practice.
No, so we'll improvise and see where we go. So we'll tell a little bit about the history, our organization, which is a little bit peculiar, but has a good reason. Then some steps in how you actually start an ISP, which is a lot less technical than, well, most of us would think about. There's more than just access. There's lots of stuff involved. Of course, there's a little bit of networking involved as well. And we have learned some lessons, some positive, some negative. So let's go back a little bit to January 2019. In January, the KPN announced that it would stop Access for All. There was a lot of news about that. A lot of people were disappointed. So immediately, Kirsten Verdel started an action committee, if that's a proper English term, and launched a petition. A lot of people signed it, I think about 50,000. Hey, this is something that should not happen. Access for All is more than just an ISP, it's more than just a brand. It stands for something in the Netherlands, and there's a lot of history going back and how it started. But
could you move a bit closer?
A bit closer, so yes, okay. Make things short, there were discussions about between Access for All, the board and the action committee, but still, KPN announced the decision is final. So there was the actiegroep Access for All moet blijven. They started in the Waag in January, and next month, February and March. The talks did not really go well. So they start thinking about a plan B. So what if KPN would really go on with stopping Access for All? We should do something. So the plan B was, let's start a new ISP. Well, that's really easy to say, but then you actually have to do something. Well, the month after that, it was really announced, hey, there will be a plan B, and there were some protests still at the Rijksmuseum, which, of course, gave a nice picture. The month after that, there was a board, what do you call it, an investor shareholder meeting at the KPN, and they made an extra entrance just to make them nice visuals. And they also had a meeting with the CEO of KPN, Ibarra, which the guy who sometime later made the famous quote, "Nothing will really change for Access for All customers." Was his quote. So there were some other things going on. There were more meetings, and KPN announced it. No, we don't want alternative plans. And then Ibarra even left KPN for other reasons, I hope.
Or for his quote.
Yeah. Okay. So the OR of Access for All did a really good fight, but failed, and we all know the results now. In short, the OR lost the court file, and so we went to Plan B. In November, we started the crowdfunding campaign, so said, hey, we really want to start this new ISP, and which is, of course, a hard thing these times in the Netherlands, because normally, if you want to start a new company, you make a business plan, you see, hey, I see some market potential, I do some investments, and I may get profitable. But, of course, here, the total reason to start it was totally different. But we started a crowdfunding campaign, and it took us 3 days to get 2.5 million euros. And those were loans. But that meant, okay, we're not the only ones who think something should actually be done. We have a lot of people who are standing behind us, that support us, and really want to pay with their wallets, says, hey, here's some money, please make a nice company. So, we did. So, at November 11th, 2019, almost 2 years ago, we announced, okay, we start Freedom Internet. There was a new name. People could sign up as a founding member. Said, okay, you get a special privilege. You will get a stamp to be a founding member of this new company. And at May 1st, we also got an AS number, and we really started. The founding members originally only could apply for an email account at freedom.nl. But, of course, we needed some infrastructure. We got a nice AS number, and we started with that. Well, we're working very hard to realize all this. And, of course, having a growing company, we needed more money, because it's really nice and dandy, all that. But the problem with starting an ISP is you have to invest in your customers. It takes some time before you really start earning money from them. So we needed some more money. We did the second crowdfunding campaign this year. And, well, it went a little bit slower. It only took 2 weeks to raise 4 million. And this time, people could really invest into them. The first one were loans, but the second crowdfunding, people could buy certificaten, which are basically shares without the right to have a vote. But people own a little bit of the company. And we got more than 1,800 investors. A lot of them were not companies, but consumers. And on average, people invested more than 2,000 euros, which really is a lot. So it still feels like a privilege that we have so many people who are really willing to invest in us and believe in us. So now we have to live up to the promise. So, this is your part? Yeah.
That was your part, but okay. Yeah. I can tell this too. Yeah. The Freedom Organization is actually a limited liability company. That's the big square on the bottom. That's where we work, where we are employees. And we are initially, before the second crowdfunding, we were owned with 100% by the Stichting Appeltaart. This is a foundation that oversees us, that is basically the owner of the company. And next to that, Bits of Freedom, which is a privacy organization, registered the freedom.nl domain, and they lent that to us. We have it on loan, and if we do not live to our promises, then Bits of Freedom would take freedom.nl away, and we are screwed. But as Reinhard already said, the first money was a loan. It's strange money. You need to give it back. So we had a second crowdfunding campaign where people could get a certificate on the shares of the limited liability company. And so we had a second Stichting Appelpunt. And the Stichting Appelpunt, you could get certificates from them for a share of freedom. And Stichting Appeltaart and Stichting Appelpunt both have 50% of the shares. Next to that, I forgot to say, that is een raad van advies, an advisory board, just as the first speaker had in their organization, some well-known people that give us solicited and unsolicited advice on our operations. Then there is money involved. So if Freedom Internet would make a profit, then we would give dividend. 50% of the dividend goes to the Stichting Appeltaart for doing good things. And 50% goes to the Stichting Appelpunt, which then will pay dividend to the certificate holders. This was also my part. But you can do that.
Yeah, let's. When people sometimes ask why this complicated construction, but there's a few nice things in here. Bits of Freedom has loaned us our main domain name. And that means if we totally start doing strange things which are not the intention, they just take it away and we're out of business. So there is a real good watchdog. And also the construction with the Stichting Appeltaart has also made sure we're not easily to be bought by some other company. And that's the whole purpose of this company. We want to be independent and not be bought in a few years by some big multinational or American company, just so we can stay focused on improving the internet. And once we start making money, which will probably take 1 or 2 years, depending on how fast everything goes. But the future, of course, with COVID is a little bit different than we originally thought. Once we start making money, the meaning is that we can start doing projects to start fixing the internet. Because we all know the internet these days is a little bit different than we thought it would be 20 years ago when a lot of us started working on the internet. And we can still fix things, but we might have to organize projects to do that. Well, the whole purpose of Freedom Internet is to be a good internet citizen and actively help projects that will improve it, like the NLNOG ring, but not limited to things like that. So we have a few nice guards in place to actually stay focused and keep being the company with the intentions that we have. And some people might also think, hey, the Stichting Appeltaart and Appelpunt is also a tradition way going back, not only at Access for All, but even back to Hectic, where the traditional reward for all the questions they asked was always, you can win an Appeltaart. So all those old traditions still are continuing, and we try to keep the old spirit alive. So, now back to you.
Yeah, they are really continuing. Sometimes I can't see an Appeltaart anymore. But yeah, starting an ISP that's we're talking about Access for All. In those days actually it was new, so it wasn't simple, but now it would be pretty simple, right? You just make some connections, and you make a connection to the internet and your business. But yeah, there is money involved, and money means contracts, and that means hassle, and then there is more money involved because these last lines are not phone lines anymore. Well, yeah, they are used to be phone lines. We are DSL connections. They're fiber to the home, and we can't dig to every house, so we have to have access providers involved, people that have the last mile to the homes, to the consumers, and that means more contracts to these people, and those have consequences, because what if a customer leaves? If a customer is unhappy with, for example, our TV service, then he would cancel his contract, but you still have a contract with this can I do this laser pointer thing? Well, between us and the access provider. And the access provider says, well, the contract says that the line is for a year. So then we have to pay for that. So that comes really with consequences, and that has more a consequence, like what if somebody moves? Actually, a customer moving from one house to the other is remarkably complicated. Because he needs a new line first in his new house and keeps the line in the old house. What do you do with your contract? What if the technology changes? Because we provide a modem or a router to the customer that has, for example, DSL modem, but this new house has a fiber to the home connection and needs another modem, or the other way around, it needs another speed with a different price. What if he has fiber to the home, but it is Ethernet or active optical networking, AON, and the new connection is GPON, needs a new modem? Or what if, for example, the modem fits, but the connection in the home is an APC connector, in this new house is a PC connector, or the other way around, and the customer just takes the connector width and plugs it into to the other side, and things don't work. Remarkably complicated. And when can we cancel the old line? Because sometimes a customer moves to a new home, and the new home is still being built, and he would move at the 1st of September yesterday, but the new home is not ready, so he still sits in his own old home. You don't know that all, because also the access provider abstracts the connection as well. And even more complicated if you have multiple access providers. Somebody moves to the other. And this is all very, very complicated, more complicated than you think. And there's more involved. We have lots of other services than just access. And that is what Reinoud is going to talk about.
Yeah, because, well, in the old days, like most of us started, it was just a connection and the rest was done. But of course, email, a basic thing, is not something you build in 1 week. So we have some external parties that help us. We have one for email, we have one for television, which is way more complicated than it originally looks. We have telephony, but also something simple like your modem or your router at home. There's a manufacturer involved where you say, hey, can you please put in some configurations that work with us? But, well, we don't have a stack of those in the office, so we have a logistic partner that handles sends all those boxes to the customers with the right connections, of course, but also handles the returns. People that cannot install it themselves, we have to have an external party that sends engineers to homes to help people install all the stuff. Of course, we have to have some financial administration that has a payment provider. So we have lots of external companies, and well, of course, here in the picture, you also see RIPE is involved somewhere. We all need RIPE, but well, if you go to RIPE and says, hey, we want a bunch of IPv4 addresses, well, that's not as easy as it used to be. So there are some address brokers involved, and then, okay, the money. We still have to get in some money to actually run the company, so we have to send out invoices, have a process for that. So it's lots more complicated than just the technology itself. There's lots of contracts involved with external parties, lots of APIs, lots of whitelisting, testing, setting things up, and of course, nothing is stable because next month we're going to announce some new service, so we have to work with extra new external parties or change the things we're working with external parties. So it's not as simple as it was. And even the networking itself is complicated. We have an order management system that's called SOMS, which is SOMS Order Management System in the GNU fashion. We developed that in-house. We have a few programmers working on that because that's where all our business logic lives. And of course, there's synchronous messaging and asynchronous messaging because not everything you want will be ready in half a second. Some ordering might take some time. So this is the part we decided we really need to build ourselves, and it's communicating with all kinds of external parties. What you see here, something like antivirus. People expect it, but okay, how do we get it? How do we get licenses at people's homes? Where do we buy it? Where have we got an inventory of which are still available? We have some resellers because there are some sites on the internet where you can just compare different ISPs. Well, if you want to have those, you need to build something as well. And of course, we have exit providers, and we will have more exit providers in the future. Not all of them work exactly in the same way. So it's hard to do stuff like that. And of course, there will be more external parties. We have all kinds of plans for extra services, which are not announced yet. Some we will build ourselves, but some we say, well, something is out there and we can easily provide that to our users. That might be faster and better. So we built an order management system and made it as generic as possible because we don't know today yet what it will have to do tomorrow. So, of course, we have some internal tooling as well, and we try to keep it as standard as possible. We do some provisioning, and we did it by Ansible, which we didn't even draw here because, well, that's something almost standard. We use external services like PagerDuty. We use a ticketing system because a lot of the people, almost half of the people who are currently working at us are our help desk. So we need a good ticketing system. And we have the standard stack. I think the most things are pretty well known. We use Grafana, we use Prometheus, we use Elk, Elasticsearch, Logstash, Kibana. We use LibreNMS to watch our network. We have a forum site. We don't have a news server these days anymore, but we have a forum site which runs on Discourse. Of course, we use a GitLab instance for our source code repository. We still use Jira and Confluence, which are external American companies, but we are looking to alternatives for that. But we have a nice few alternatives. We have Snipe IT for asset management because, well, the number of assets you have in a company explodes when you start up new things. One of the really good choices we made was using Netbox as the CMDB, and we have everything in there, VMs, networking. It's our main IP registration, and it also acts like primary DNS for reverse DNS and our internal DNS. Of course, we use Power DNS for both our authoritative DNS and our recursive DNS. We use FreeRadius, and of course, Genie ACS, because we have to manage a lot of modems and routers which are working at people's homes. So there's a big tool set involved, and you have to stand it out of the ground as fast as possible. And one of the hard things, of course, is that, well, you can make a nice plan for that and say, hey, let's design a network, let's design a complete tool stack, but some things will have to start working tomorrow. So, but I think most of the technicians here are used to that. You can make a nice plan, but the business always requires things to be ready now instead of really building it up in the way you want it. So.
Yeah, you already described the next.
Yeah, I described everything already. Yeah. But for the people who really like the words are in there. We also designed the internal network to be nice and safe and separated because, well, if you use a lot of different applications, I assume that one of those will be hacked at some point in time. So let's design our network to mitigate those problems as much as possible. So we made what we call silos, which are different compartments in the networks, and all major applications run in their own silo, and access to other silos is as minimal as possible. We do a lot of filtering in there. All services that are available to the internet are behind a load balancer. So that also an extra layer of defense. All the silos, of course, we make a lot of them. So to minimize the configuration networking-wise, We use OSPF for that, so then the other ones can fight each other. And yeah, like I said, the front proxy is our main guard for the outside world. We, of course, use VMs, and our platform for that is Proxmox, so we can make them by hand or script those as well. And that's basically keep it as simple as possible. It's already complicated enough, so we try to make standards and as little exceptions as possible. Internally, we use mainly IPv4. Of course, at some places, IPv6 is needed for some applications. We considered using IPv6 only, but not all applications are ready for that, alas. So we still need to have a mixed stack. So, the networking.
Yeah, this is the typical ISP network. I start from the bottom. You have the last mile, the CPEs on the bottom, and they go in via an access provider into a BRAS, a broadband access server. Then it's IP routing internally. You can go to our servers that we just described a bit, for example, DNS, or up to the internet through our BGP routers. This is a very typical ISP network. It's basically pretty boring. The last mile, we use PPOE tunnels. These are terminated on the BRAS. And the reason to use PPOE instead of DHCP is because the access networks, they are very diverse, and they typically do not support IPv6. They do not have DHCP v6. And to use a PPOE tunnel, you become independent for your services on the access networks. The BRAS talks with the radius servers for the authentication and authorization. And their PPOE is very handy because you can enrich the signal, the PPP signaling, by a ID that identifies the physical connection to the house. So the subscriber identification is out of bounds, basically. There is a password you can type into your modem. You can type in any password. You can type in any username. We don't use it. We just look like what is the line, what is the ID that identifies your house, basically. And then we outsourced a lot. Basically almost everything. Only the upper square, the BGP routers, some DNS servers, the ACS, that is what we do ourselves. And the rest, it's all outsourced. And that is also more work than you think. That's why we had this SOBS, that's basically the spider in the web, that talks to all these different parties to order, to cancel an order, to change something. To do that. The access is done by another ISP that has the contacts with the access provider, that has the contact with the last mile providers. They also do radius. So we have an API telling them, like, these are our subscribers. They assign the IP addresses. Basically, we do almost nothing. And we still have a lot of work to do. What we're going to do, this is more in the future, we're going to insource the BRAS and the radius servers. One of the reasons is IPv4 allocation. There's a whole section on that I'm going to talk about. But to go a bit ahead, we would like to change IP addresses sometimes because IP addresses, IPv4 addresses that we have are often not so good. And I come to that later. It might be, because what our unique selling point will be is that we can have different access providers, different fiber to the home projects that are all over the country to have contact with that. And some of them might require that they run the BIAS. And now are like experimenting, thinking, can we run radius ourselves? Can we get things like syslog or flow data in from an external BROS so that we can still do the subscription, the subscriber administration ourselves, that we can still do the troubleshooting ourselves, because one of the big problems with outsourcing is troubleshooting is way harder. You don't have the logs, you don't have flow data, you don't have, basically you don't have anything. You either need to build an API for it, or you need to ask other operators that also like buried in work. The current network also has some redundancy issues, and that is not the fault of the partner that we work with for the access. These access providers, they have a rather curious way of doing redundancy, namely you have a number of links, this is this village, that is that village, and you bundle them together in a link, and now you have the redundant link that are different villages in different cities. So if this if one link falls, then the rest of the country is still available, but other people not. I think it's curious, but that's how things work in access world. And basically the current situation is that there are two BROSs, one does a bunch of modems, and the other one does a bunch of modems with a third-party access provider in between. I want to get it something like this, that these things are redundant, that only this last mile to one individual house, okay, that is then not redundant, but the rest should be redundant. This is going to be a lot of work. And I want to go to multiple data centers, because right now our equipment is in NICHEF, and at some point we need to make that also more redundant. The top part, to all the different providers, to our own servers, we make as redundant as we can. And then the lessons learned. You started already a bit about the legacy.
Yes, of course. As you all know, once you start a totally new company, you can take all the lessons learned, all the experience you have over the last 10 or 20 or 30 years, depending on your age, and make something totally new, and you don't repeat all the mistakes from the past, right? Sure. Yeah. So, now back to the real world. Of course, there are some things that are rushed. To be able to start at November 11th, we got a lot of help from all kinds of people around us that just hacked some solutions together to make a working website, to make an ordering site. Lots of thanks to all kinds of people. I cannot name you all personally, but we're really in debt to you. But of course, that means there's a system which works totally different than the system we designed and are building. So from day one, you already have legacy. And as we all know, legacy is really hard to get rid of. Our first system was still used a long time to just look up, hey, how did these people actually sign up? What were the dates? And of course, it was in a totally different format than our new system. So the conversion, yeah, we could convert that data, but yeah, that's a lot of work, and we already have a lot of work. So just let that old system run for a while. And of course, a while is always longer than you think. So it's easy to introduce, even at a new company, even with a lot of experience. From day one, you have legacy, and legacy is always hard to get rid of. We had an infrastructure which was always also really a few donations, a lot of hardware we got. Also, thanks for the partners who gave that to us, but we want to have a different structure, and moving all those VMs to our newly designed network took way longer than we had hoped. So it's, yeah, everybody knows it, and it's still true. Legacy is easy to introduce and hard to get rid of. So.
Then IPv4 LRS space. We got 2/22s, I think 23s from Wipe NCC, and that's not enough to run an consumer ISP on. We did consider for a little bit if you do DS Lite, where we do only IPv6 and we tunnel and we do NAT on IPv4, but that wouldn't really come up to our quality standards. So we went from IP brokers, we went IP addresses. And in that sense, it was a pity that there is no quiz anymore on the end, because otherwise I might have gotten another /24. But we get this address space from all over the world from brokers, and then you get really weird things. Like Twitter, people getting Arab advertisements. And this is a bit amusing, but you also have people that really are blocked because they appear to come from an Arab IP address for their work. Then we have people doing all kinds of blocking. This is done from a small publisher company that still didn't manage to get rid of their security product, that basically incorporates MaxMind's GeoLite free database. And that's like a static database that goes in that WordPress security product. And only when you update it, there might be a new database in it. So it takes a really long time before you actually get your addresses done. And then you call these people. And then you get things like, well, of course you have to request Dutch addresses. Where? From the Dutch government. Or you have to get them registered at the Dutch government. And this is not one. This is a lot of sysadmins have that idea. Or you get people say like, oh, well, our sysadmin really knows the internet, and he says, talk to KPN, because they do the internet. Or talk to your ISP. I am the ISP. So this is a considerable amount of work goes into clearing up these IPv4 addresses. But there's also like fun things then, like people that just unblock you and make an exception. People that actually, quite a big media organization in the Netherlands, figured out that they paid MaxMind for years, but used their free product. And thanks to us, they actually figured it out. Or a large organization that somebody started to run into the organization and finally got everything unblocked, and is very happy that she knows now how it works. And then television. Well, if IPv4 addresses are a nightmare, television is really a nightmare. And that has largely to do with television rights. They are expensive and they are weird. Expensive in the sense that media channels want to have all their channels into your basic package, but costs a lot of money. Or things like, we have these markers that starts where this program starts and program ends is for advertisement. You cannot use them for recordings. You have to have a human doing that. Why? I don't know, but that's apparently what is in these contracts. Also, well-known things as you cannot go fast forward to advertisement and stuff. A lot and lots of pesky things into these contracts, which made us to outsource television. And we outsourced it to a party. We didn't have much choice to outsource this to different parties. And the quality of this party was way below par. We got really a magic fuck ton of complaints about this. And the first one was their STB. That was a really old-fashioned product, like 1990 user interface, slow, didn't work. And luckily we got this replaced by a more modern STB, but the quality remained below par. So this is what the Consumentenbond said from it, that we got a 5.7, and if you are like in school, 5.5 was enough, I think, but this is basically the mentality of this company. And then, you have to troubleshoot it. But this television, that's multicast, goes directly to the access provider. It doesn't traverse our network at all. Basically, there's nothing to work with, except you can ask complainers to to make a PCAP, make a TCP dump on the modem. That's a possibility that is in the modems. Send it, and then we knew that that they use RFC 1918 addresses, and we got a bit slow, but we got so in contact with the network people of the television provider, and they said like, oh wait, you're using those RFC 1918 addresses? Well, we use them internally as well, and that means that our decoders would not cache, because we switched it off so that we can test easily ourselves, which meant that a large part of our customers got live encoded television, and that doesn't work really well. So using RFC 1918 addresses over different companies, and they basically pushed by us started to look at the data the STBs can provide to them, and then we saw that a lot of retry traffic, so most of the television, live television is multicasted, but the STBs can say, like, well, I didn't get that frame, send it through unicast to me, that's retry traffic, and you can really see a clearly distinction between fiber to the home providers and DSL providers. Multicast works remarkably well on DSL, and not so well on Ethernet fiber to the home, and I suspect that has to do with multicast forwarding capabilities into switches, and I suspect, I don't know, but I say it anyway, I suspect it hasn't really been tested well. But the RFC 1918 addresses and some other things, things improve a bit. I would not say it's smiley in here, but it improves a little bit. And then...
Yeah. Now, one of the things you forgot to mention is, of course, we have a lot of external parties we're working with, but because of the rights of television licenses, we could not resell the television product. So our customers are, when they order television, will become a customer of our television partner as well. So we looked at their algemene voorwaarden, and they said, yeah, well, these are not what we really accept. They might be standard in the television world, but we don't accept them. So we took a nice battle with them, and we actually rewrote parts of those terms of, what's the English term? Terms and conditions, thank you. So that actually benefited all the other customers of that company as well. So that's the first step in improving the internet for us. But one of the lessons learned, also, we have a loyal fan base, which we can only thank. I think a lot of them are here as well. We have a lot of founding members, we have a lot of investors, and a lot of those are also in the Consumentenpanel. The Consumentenbond does these researches about all kinds of products, about the best stuff to wash your dishes with, but they also do some investigations about internet providers, and we were voted the best provider overall, even with our under-par television products. And well, we have a lot of goodwill, and without those loyal fans, we would not be here today. So it's really cool that there's a lot of people in the Netherlands that actually believe in our mission to say, hey, there should be a company that's not owned by some big shareholder investment structure that only wants to make money, but a company that still has the good spirit to do the right thing and to solve the internet problems. So we have a lot of goodwill, a lot of investors, and by now a lot of owners, because like I said, we had 1,800 people invest in the last crowdfunding, so we have a lot of people to keep up our promises. So that was basically it.
Yeah. Thank you. Thank you, Reinhard. Thank you, Arjen. Other questions? I see Jan Zorts has a question. Yeah. Go ahead.
Hello. Jan Zorts from Six Connect. So many questions, but I will just ask 3, okay? Okay. Of course, IPv6 What size of a prefix did you decide to assign to the customers? And are you assigning it dynamically or statically? And for IPv4, do you give a public IPv4 address to each customer, or you're doing CGN?
We give a public IPv4 address to each customer. One modem gets one public IPv4 address. It's static. Same goes for that it is static for IPv6. Everybody gets a /48.
Thank you.
And we will start to give people, there's still a few people who require IPv4 subnets, and we will start offering that as an extra service, I think October.
Yeah, it should be live on October, and what we tend to do is there to set up a sort of route reflector that sets the next hop of that little subnet to the modem of the customer.
Joris, next question. Go ahead.
Yeah, Joris Klaassen, Arista Networks, and also Freedom Investor. I happen to live in an unlucky location right now, where there's no fiber to the home, and DSL, pretty much sucks. Now I know that ACM did open up, or at least get some legislation in place to open up the cable market as well. Are you looking at that for access too?
Yeah, when I just joined Freedom, that was a court case going on by the ACM saying, like, Ziggo, you need to open your network for others. We were in talks even with Ziggo for that. But then the ruling was, no, you don't have to do that, Ziggo, and also KPN, you don't have to do that. Okay. So that went completely other way than expected. We would love to go on cable as a sort of second provider.
Okay, thanks.
See, we have another question. Go ahead.
Hi, Carl again. Do you guys have good lawyers and negotiators, so that lawyers for your GDPR and other compliance, and negotiators for escalation matrices that match the ones you present to your customers?
Yeah, what is good? We do have a legal scholar that works for us, and the rest I can't really say. Do we hire somebody?
Yeah, of course. One of the board members, Shura, in the Stichting Appeltaart, is also part of the privacy company. So we have lots of contacts around there, and of course lots of help offered by people as well. So that's part of our loyal fan base.
But talking about the negotiators, because you outsource so much. So, for instance, you promise your customers you'll have them up within, say, 6 hours, for instance. And if it goes to the next day, then it gets escalated to the next level, technical and managerial level, and so on. But if you're depending on another provider, like the access circuit provider, then their escalation matrix would have to match yours, so that if you promise 6 hours to your customer, then they promise 6 hours to get your connection working again as well.
Yeah, I'm not exactly aware how the escalation matrices fit together. I do see that we didn't foresee a lot of things beforehand that we're now bumping into. That's large part of the work, basically. So, yeah, in hindsight, you might have foreseen things and put it in contracts. In the end, also, it has to do with the capabilities of the access provider or the other providers. What is available? How much resources do they have available? And it tends to be that the larger the company, the more difficult it becomes. But when it's a really small company, then it also just people are strained on resources to do things. And a consumer ISP is that is about big numbers. It's about a lot of people. So you need to do a lot of help desk work, and then funnel that into to some kind of question towards the contractors. So outsourcing, there is indeed a lot of work in making good arrangements and having good communication. And with one company, it goes better than with the other.
Okay, thanks.
All right, thanks again, Arjen. Thank you, Reinhard. Before we go for lunch... Well, let's... There's more before we go for lunch, and Niels will tell you all about it.
Yeah, because the next part isn't that relevant for the remote viewers, because they can have lunch any way that they like. But for you guys here, it is a little bit different. There are a number of rules. Lunch will be served downstairs, as usual, but it will be packed. So there is one lunch package for each and every one of you, and there are plenty of them. What is important is that the room is split in two. So there is this camera here, and then you have this line that starts roughly at Mark and then goes to Paul and Jurian and Robin. And that is the half of the room. So this half of the room goes through that door and will get their lunch at the basically at the bar side of stuff of the downstairs floor. That half of the room will go out through that door and get their lunch at the restaurant part. Once you have your lunch, you can go sit anywhere you like, inside, outside, no worries. But you sit. If you don't sit, the only reason you don't sit is because you're on your way to go sit somewhere else. If you sit inside, you can order drinks at the bar. If you are outside, you can order drinks through the James app, and all the details of this app are on the tables outside. If you listed any dietary requirements, then your lunch package is at the bar. So please report at the bar with your name, and you will get your special lunch. Did I forget anything about lunch? Oh yeah, there is 1.5 hours. So no hurry. You can leave space. You can take time. Doesn't matter at all. 1.5 hours. We will be back at 13:30 CEST with everybody well fed, I hope. And then we shall see you healthy again at that time. All right? Enjoy. Please take your time. There is plenty of lunch. There is plenty of space. Would you please take your seats? Nou, heeft Thomas iedereen naar boven gestuurd? Denk ik wel, hè? All right, let's get back to the program. Welcome back in the room. I hope everybody had a nice and healthy lunch. Our next speaker for the day is Sascha Romein, and she will be talking about IRR Explorer. And maybe this is something that you didn't really know, but IRR Explorer is more or less the responsibility of the NLNOG Foundation. The first version of IRR Explorer obviously was written by Job, and I wouldn't dare to comment on Job's code. But there were one or two issues, so it was time to find a professional. Which the process started by finding sponsors to pay the professional, which is what we did. And we found the professional, there she is. And she's now going to tell us about IRR Explorer version 2. Sascha Romein.
Thank you. So, yeah, my name is Sascha Romein. I am a professional. I've done over a decade of being a professional software engineer mostly. I do a lot of Python, Django, lots of other stuff. Used to work at RipeNC a long time ago. A lot of my work is open source, which is more fun. I get to share things other people contribute from the community. And I'm not quite a network operator, so like different from the average here. I do have my own ASN in the DF set. And other than that, I also do all sorts of community organizing. I'm on the core team of a documentation community, Write the Docs. And I'll start briefly, I think this is known to many of you, but about what is the Internet Routing Registry, basically. For the relevance for IRR Explorer, basically, it's you can register routes that you or other people intend to announce. There's kind of has a lot of fuzzy edges. There's registration data also in some of them more than others. There's all kinds of other things. Some people put poems in there, some of the databases. But there's lots of, there's a number of automated tools for building filters based on IRR data, like BGP Q4. And there are a number of different registries. There's about a dozen that are well known and popular in different sizes, different policies. Some of them are free. Some of them are very restrictive on their data. Some are more liberal. And a lot of them mirror each other's data. And IRR is pretty old, so there's a lot of legacy in both the data and the code. There are some strange things in there. Some of the code is old, unmaintained, and especially the last part is something I've been working on a lot. And like was just said, the original version of IRR Explorer was built in 2015, mostly by Job, but lots of other people were involved as well, lots of community contributions. And this is what the old one looked like. It's much prettier now. And the goal is basically to give people insight into the IRR records, the BGP data, and RPKI for a prefix ASN or ASZ. The goal being that it would, to make it, to give it insights for yourself, but also for customers. So I say if you do IRR filtering, your customers don't understand why their routes won't make it through your filters. You can send them to IRR Explorer and they get a nice overview that is more accessible than sending them to various whois records, various databases where they should be creating route objects. This is like a nice quick overview that makes it easier to help yourself or help other people set up IAR correctly. But also as mentioned, like there was a lot of room for improvement in user experience, reporting, maintainability, correctness. And also in the meantime, since 2015, I worked on the Internet Routing Registry daemon version 4, which is a rewrite of the legacy IRD and released 2 years ago. Years are hard. And so I built this project originally for NTT, and this is basically the server that answers IR queries, that answers whois queries. It's now in use for NTT.com and Erin and LACNIC and TC. Some other people are looking into it. And it also handles authoritative object changes for some of these. But importantly, it also has a big overlap with things that IR Explorer used to do on its own. So the original IR Explorer would run its own mirrors of all the different registries, would collect its own data, parse RPSL records. But actually, all of that is in IRD as well, and the new version, this is implemented very well. There's also completeness, like complex elements of set resolving that old IR Explorer just ignored. And so IR Explorer v2 is a complete rewrite by me in Python and React.js, and it builds upon all the work that I put in IRD. There's a very nice new API in there that lets you query RPSL data in nice JSON also, so you don't have to parse all the individual RPSL fields. You get all the, so this is a very practical way to access IR data. And there's just a lot of improvements in the reporting, in the user experience, maintainability also, because there's other ideas of how to develop this further, and also it's more complete in a number of cases. All this work was funded by RIPE-NC Community Projects Fund for Stichting NLNOG, who then hired me to actually build it. How does it work? Like I said, for a very large part, it is built upon my work for IRD4, which mirrors a number of registries, basically whichever you want to configure. Those are all the common registries that you've known, like RIPE, Erin, NTT.com. They get mirrored into a local SQL database, and then IRD also does RPKI imports and validation. So it takes RPKI data, translates that into sort of fake route objects, but also validates all the other route objects, whether or not they are RPKI valid according to RPKI origin validation. And then that's all exposed on the GraphQL API. GraphQL is a query language which returns JSON. Then IR Explorer itself gets data from RIR stats to figure out which RIR is this address space registered with. BGP.tools gives info on what is seen in the DFZ and also how many people see this, which origins are seen. That all goes into a database. A data collector aggregates everything and also figures out what should we actually look for in which registries based on the user query. That's enriched with reporting, goes into an API that is rendered in a React.js frontend. All the green parts are Python, and the other part is React. So this is a new tool. It's already live on irexplorer.nlnog.net. And here's an example report for an ASN with all the prefixes. This is the most extensive part of it. I'm not going to name the AS, but someone in here is managing this, but it's not too bad. You can see, for example, on the top, there's a prefix 9120834, which is registered, which is RIPE-NC address space. In BGP, it's AS8283. There's a ROA for 8283, max length 24. There's a RIPE route object for 8283. So this is all fine. Like, this is all consistent. There's nothing unusual. Everything adds up. You can see some of the blue ones where there is a ROA for origin 8283, max length 24, but there's no BGP announcement that we can see. There's also no route object, so IR Explorer highlights that. This isn't bad necessarily, it's not an operational impact, but it's This is like, I don't actually know why these people are doing this. I've seen other people do this, so maybe there's a good reason and we should update this report. But it's highlighted as in, this seems odd. And then also you can see one red row in there, 185.52225, which is in BGP with origin 8283. There's a ROA for 8283, but there's no route object at all. There's an overlapping /22, which is fine. So if this is your network, there's no rush to fix this. But this is probably an error. I say probably because IR Explorer tries to detect things that seem off. So especially in terms of whether things are red or blue or green, it's sort of a best effort on highlighting things that you might want to look at. There are people who do unusual things that make sense in their situation that are not always detected by our Explorer. But it helps for a lot of cases. Another thing it does is find other prefixes that overlap with prefixes that are associated with your AS. So for example, in the top part, you can see there's one prefix in a PNIC address space with also a route object in the PNIC database. There are a number of less specifics there. They're probably not very relevant in this case. Old IR Explorer would just put this all in one big table. But in some cases, these are sort of adjacent address space that are in some cases also very relevant to you. Another example, this is froot. And so froot has two prefixes, a /23 and a /24. It's not RPKI signed. For the /23, there's one BGP origin, one RDB route object. They are consistent. There's no record in the ARIN IR though, which is why it's highlighted. There's also no RPKI ROA. And also, in some cases, you would not see a RPKI entry on the same line because RPKI, you can do max length. So there could be a less specific ROA with a max length that makes this valid or invalid. And IR Explorer detects all of these. But also, you can see that for /24, there are other route objects in RDB. There are other origins, entity com as well, which I don't know why people created them. There was no, you can pretty freely create them. But with IR Explorer, you can also dig into them and find out what these objects are, how you query for them. Also nice for less experienced users who don't really relate what they can query in Whois to IR Explorer. So you can dig into these objects and figure out where do they come from, who is managing them. Another nice feature that's new is you can query all the data as JSON. So basically you can get the exact data that was used to render this table. This is basically just the API call. The API call isn't really specifically documented or guaranteed to stay, but you can use it if you want. So this is everything you see in that table. So there's an IR route, status is not found because there's no RPKI data. There's all the warnings, there's generally how good or bad this entry is, and things like that. This example is RIS. And I use them because they do bad things on purpose. And you can see, for example, first row here, there's a prefix that is originated from 55303. There's actually a matching route object in RDB, but it's a PNIC space, and the PNIC IR says the correct origin is 12654. So that's why this is highlighted. Probably actually in this case, I think it's the PNIC route object that is old and left over, and maybe it was temporarily used by RIS. And you can basically see most kinds of errors appear here. Also, I think you can see some of the ASNs have a check mark or a cross behind them, which means that that object is RPKI valid or invalid according to the ROA data that we have. So there's announcements in here without any route objects. There's conflicting route objects. There's one where there's a different BGP origin, different route object, and different RPKI. And these are all detected. I also like this one. This is new features also. We support prefixes that are announced from multiple origin ASs. So this is the worst one I found, I think, with about a dozen different origin ASs. And The route objects do actually all match. So this is valid, but highlighted because multiple different origins are unusual. I think this is anycast being used from different origin ASNs, which is not common, but people do it. Also, AS sets are included in IR Explorer, so if you query for ASNs, you can see which AS sets your object is included in, but also the other way around, full expansion in depth of AS sets. So for example, AS Open Peering Peers has these direct members, but you can also explore further and see, for example, that at 3 levels deep, AS Apple is included through the path, AS Open Peering Peers, AS RTN, AS Apple, which then has members, and this goes all the way down until at some point we stop expanding because your browser will run out of memory. And you can also see interesting things. I still want to add more reporting for this. For example, here at AS Open Peering Peers directly refers to ASNet, but there's 3 of them in 3 different databases, in NTT-Com, right, and APNIC, and they are all different. Which is sort of a challenge, also something I've encountered in IRD with. AS set expansion is AS set names that we refer to are not actually unique, and sometimes they're wildly different. These are, as far as I could find, also owned by 3 completely different organizations. So 3 completely independent people have chosen to create the same one. Which one did AS Open Peering Peers mean to refer is, I don't know. Yeah, I do find other unusual stuff. If you query 0/3, there's a route. There's some unusual route objects and things in BGP that you run into. Like I said before, usually you can't actually query this. There are some limits on how big you can query for. I did actually try, like, what if I query like almost all the IPv6 header space and my browser died at a few gigabytes of RAM? So there are some limits. If you need to do these kind of things, then we should talk, because I'm sure we can build some kind of reporting tool around that. And so that's IR Explorer version 2. All the code is on GitHub under a fairly open license. So if you're interested in new things or think the reporting should be tuned, there's probably cases where the reporting is slightly off, then do make a GitHub issue, a pull request. And thank you.
Right, well, thank you for improving this software so much, Sasha. It is really helpful to the operator community. As somebody who believe has enable on AS8283, I would like to say that these weird things are not so weird. They are for anti-DDoS. So
I thought so.
I think we're okay there. Any other questions for Sasha? Martijn.
Yes. So thank you for the IR Explorer. I love the tooling, but I have a problem. If I enter my AS set, it breaks down. And this is because one of our downstream customers has claimed the same AS set name as a certain Chinese incumbent in the RAR-operated databases, whereas the Chinese incumbent is doing things in RADB. So because we are not really trusting whatever is going on in RADB or other third-party databases, for us it would be very relevant to only see on the RAR-operated databases, right? The clean routing registries. Is there any plan to kind of give you filtering capability so that you can only expand from, let's say, a subset of all the IR databases?
Not yet, but we could do it. Like, it's not difficult. So, yeah,
that would be very wonderful.
You're talking about AS set expansion, right?
Yes.
Yeah, yeah.
Yeah, so in my AS set, there is a different AS set, and in APNIC or in RIPE, it means something different than the one in RADB, which is huge.
Yeah, the more fundamental solution is that we stop using things as primary keys, which are actually not unique at all. And I don't know how that happened, but it was a very poor choice.
Unstoppable force versus immovable object.
Right, thank you for the feedback, Martijn. We will also take that up in the board, I think, because if a new feature needs to be added to IRR Explorer, we will work that out with Sasha. So thanks again, Sasha, for your clear presentation and your great work. And then it's time for the little dance again. Will you do the wipe down, or shall I do the wipe down of the microphone this time?
And I'll find the presentation.
Yeah.
Because like our next presenter is Roman Dodin. He will be talking about a tool that makes it really easy to build containerized labs from CLI. All right, it's all clean. Go ahead.
Yes.
It's all yours.
Is it done? Hi, everybody. Let's talk about running networking labs with Docker user experience. Since I'm new to NLNOG and to the Netherlands, let me introduce myself. Hi, I'm Roman. I'm a systems engineer with Nokia, and I work primarily on things that have to do with model-driven network automation. I do love open source communities which are built around networking, and I do contribute to them. If you want to talk to me, reach out either through LinkedIn, or I'm quite active on Twitter, and this is my Twitter handle. Since we are short on time, let me just jump over to the first meaningful slide, which is how do we run networking labs today? Because we do love to run labs, right? That's the only way we can blame the vendor, for instance. And there is one thing that is kind of an elephant in the room. The network emulation software projects like EVE-NG, GNS3, and a few smaller others, they are purposely built for that. They are proven. They've been running in our labs for decades, and we know how they work. They are quite free and available to download to everybody. Some premium features of EVE-NG might require some extra bucks, but yeah, for the most of the part, it's really free. They have a nice UI, right? We can drag and drop our elements on the pane, we can interconnect them with links, and that's our topology. That's really great, useful, and human-friendly. On the flip side, what I think these tools kind of lack of is that they have a very VM-centric approach. That means that inherently they have weak container support. I will talk later about why I think container support is really important here. But yeah, that we will leave for later. They are also quite heavy, and everybody knows that it's a burden to install EVE-NG or GNS3. You need either to have a bare metal server, or you need to have a VM, and these will be allocated for the long period of time. You cannot bring this environment up and destroy it after. It will be there with you for a while. Also, what was previously a plus, the UI thing, it might be considered a minus, because if you are on the development side or on the testing side, you might be more comfortable with textual-based configs, like YAML configs or TOML or whatever you have. You might be just looking at this as the artifact that you would like to type in and not drag and drop and click around. In the other bucket, there are tools like OpenStack or Proxmox with the VM orchestrators. You might want to use them to create networking labs, and they are quite popular. They're in numbers in medium and large enterprises. They are there. The problem with these tools, though, is that to run networking labs specifically on those projects, it requires quite a lot of integrational effort. You need to know how tools work, how to interact with the objects that they expose, et cetera, et cetera. They are, of course, VM-centric as well, because they are VM orchestrators, meaning that there are problems to run containers on them in a way so you can use them in the networking labs. Sometimes even to get a clean data path might be challenging with these tools, because if your data path has a breach, a typical Linux breach, then you might have problems with LECP or slow protocols, and sometimes even with LLDP. There is no UI nor CLI that is really tailored to networking labs. They do have UI and CLI for the project themselves, but these elements are really for the constructs of the OpenStack or Proxmox, like create a VM, create subnet, create a router, but not create a network topology. And on the far end of the spectrum, there are custom automation solutions. Everybody have them, like a crazy bash scripts with thousands of lines that spin up libvirt VMs or create Docker containers, and they might be really a silver bullet for you. They can solve all the problems that you might have. The only downside is that they are tailored only for you. So if you want to take your custom solution and take it to your customer or to your partner or to your peer, they might not be able to run it at all because you took some decisions that are really specific for your environment and they will not fly in their environment. And now to the point where I mentioned that the weak container support is kind of important. Why do we do that? What do we gain by moving away from VMs when we talk about network labs? Well, first, of course, we will gain containerized network operating system support. And if you think that there are no containerized network operating systems, you are a bit wrong. There are a number of them, like Nokia SR Linux, Arista CUS, Juniper CRPD, Cumulus VX, FRR, and a few other under the Linux Foundation umbrella. So by moving away from VMs to containers, we give first-class citizen to those things, and that's really nice. What do we gain as well is that we can now be quite light and fast to deploy the labs, right? If you work with containerized network operating system, it is really lightweight, far more lightweight than the VM. For example, an 8-node Claw fabric can fit in a 2 vCPU and 8 gigabytes of RAM VM. That's like peanuts compared to what, for example, XRV wants to have for a single instance. Also, when you use containers to spin up labs, you kind of get or inherit all the familiar features from the Docker. You can use file bins, you can use port exposure, you can create CMD commands, you can propagate environment variables. All those IT workload things that we all know how they work, they will be available for you for your networking labs. And the thing that I love most about it is that the networking lab become really Git friendly. You can create your topology, you can check it out to Git. Somebody can pull it and create this topology right away without really going into the weeds of the UI. Also, when you work with containers, you work with container images, right? So now you can forget pushing your QCOW images to OneDrive or Dropbox. You can push them to the container registry. You can tag them with a version. Somebody else can push it, can pull it or download if they have credentials for the private repo, or you can push it to a public container registry and they will be able to pull it from there. And that is really convenient to share the images that you can build. And the last part, which is quite important, is that now you can run your labs in CI/CD pipelines which are interacting with networking. So what most of the people do with tools like EventG or GNS3, they have it in a private runner in a data center of some sorts, and then they create a pipeline that talks to this EventG server to test things. With container lab approach, you can spin up your networking lab pretty much the same way as you do with your IT workload. You create a topology, you spin it up in a private or a shared runner in the cloud, and you test your code or your feature against it. And that is where Container Lab comes into picture. With all those benefits of containers in networking labs, we decided to build a tool that provides a CLI for setting up labs with container-based nodes, right? So you can create quite complex labs, like on the left-hand side, like 3 or 5-stage Claw topology, or you can do just some lightweight labs, like 2 nodes connected together, or 3 nodes or 4 nodes, whatever you need, and then you can spin it up in a matter of seconds and start playing with it on your laptop or your virtual machine or a server. At this point, I wanted everybody to know that there is a huge documentation portal for Container Lab, and it's down below, containerlab.srlinux.dev. If you go there, you will have the documentation portal presented for you, and it answers most of the questions that you might have at this point. But to give you a quick introduction of Container Lab, I would like to get you on a journey. So we'll have 6-step journey right now. We'll first see how we can install Container Lab. Then we will get to know what is this topology file that I'm talking about? How does it look like? We will deploy a lab, and then we will manage the nodes that will be deployed. We will access and configure the networking nodes that will be part of this lab. We will work with configuration persistency to see how we can save configuration and we can boot with it. And then we will package and push it to a Git repository so everybody else can pull it and reproduce the steps. The lab that I chose for this talk is really simple. It's a 3-node lab. It demonstrates a route reflection capability of CUS, Arista CUS in this example. It consists of 3 nodes. GoBGP, a Linux container, will emit a route towards the Arista CUS. Arista will reflect this route towards Nokia SR Linux, and Nokia SR Linux will have this route in its routing table. On the left-hand side, you see the timeline of the events and the addressing that I will use in this lab, but this is just like for your information. So, installation, step number 1. We thought that Container Lab needs to be really easy to install. Otherwise, it's really hard to get anyone interested in that. And installation of Container Lab is really just one single command, which is highlighted in blue here. You can install it on Windows under VSL2, on Linux, and on macOS with some limitations of the Docker desktop. So you only need to have a Docker installed. No prerequisites, no third-party tools. It's all a single binary that has all the things embedded. So when it's installed, and it's only like 3 seconds, you can get to the actual lab. And the way Container Lab works is that it takes a lab topology file, which is expressed with YAML syntax, and creates those nodes and wires between them. And this Container Lab file, we also refer to it sometimes as a topology definition file. It's really a simple thing. So when we want to create a topology, we start with giving this lab a name. And for our case, the name would be RR, which is short for route reflection. The lab will have a topology, right? That's the third line in this example. And then topology consists of nodes and links. So right now, I want to create just a single node, or this example just shows a single node. The node has a name, and that is the SR Linux in my case. The name is just really a string. It's an arbitrary string. You can name your nodes whatever you want. It is the way to tell one node from the other. Then the node must have a kind, and kind is actually what makes Container Lab to understand how to spin this node. Is it a COS container? Is it VMX? Is it CRPD? Is it something else? With kind, you set the expectations, like what this node really is. And the third thing is the image. Container Lab works with containers, so you need to have a container image on your system or pullable from a public container registry. In our case, SR Linux is publicly available on GitHub Container Registry, so I can use this name here and it will pull it for me. Okay, this was one node. What do we need to do to create those 3 nodes with GoBGP, COS, and SR Linux? Well, not really much. We just create 2 more nodes. You see that on the SR Linux there is COS node, and the last one is GoBGP node. Right now, with this topology, like you see on the left-hand side, we will have 3 nodes deployed, but no links between them. Now it's time to add those links. To add those links, all it takes is just 3 lines. You have links section in the YAML file where you say my endpoints are, and I'm not sure why the markings are off, but yeah. So the endpoints say, the first one say, I want to connect SR Linux interface E1-1 to COS node interface ETH1. And you see this will be the link between those 2 interfaces. You just refer to the name of the node and to the interface that this container will have. It's as simple as that. It's really no magic here. But then you will have your nodes interconnected with VHH pairs between them. And VHH pairs will mean that you have clean data path between the nodes. No bridges, nothing. It's like as pure as it gets. And then when this topology file is ready, you can deploy your topology. You can use Container Lab deploy-t for topology and the name of the topology file. And 30 seconds later, you will have your lab already ready for you. It will consume only 1 vCPU and 2 vCPU and probably 2 gigabytes of RAM for all those 3 nodes. And that's it, right? It's as easy as that. Now when this lab is running and you have this Container Lab summary table with connection information, I wanted to show you how you can connect to those containers, right? These are containers, so we can use typical exec process of the containers. We can say, I want to execute srcli process in the container with the name clab-rr-SR Linux. And that's how you get CLI access. Of course, you can also connect to the SSH server. Network operating systems run SSH inside, and containerized NASs are no different. There is an SSH server inside. So you can say SSH admin at and either container name or the IP address that Container Lab assigned to it, and you will have your shell. And we will have a live demo of that, so don't worry if it's a bit unclear. So now when the nodes are ready, How do we configure them? Well, if you can connect to the CLI, the first and obvious choice is just to dab on the keyboard and something good will come out. But you can also use GNMI, JSON RPC, netconf, eAPI, whatever you have on the nodes. We try to have it already configured for you when you start the lab. So most of the network, or most of the programmable interfaces will be available once you start the lab. You can also use config mounts, so you can bind a file from the host to the container, and you will have your configuration used as a startup file, and the node will start with that. Of course, you can use third-party configuration management tools because your containers, they have IP addresses. You can use Scraply, Ansible, Nordenir, what have you, to configure the nodes and create the use case on the topology that you deployed. And soon we will have a configuration engine backed into ContainerLab that will work with labels and variables that you supply to the nodes, and it will create meaningful configurations for you across multi-vendor nodes that we support. Now, the important thing is that ContainerLab keeps some state. When you create a lab, and we talk about the lab with 3 nodes, ContainerLab will create a lab directory. And this lab directory will have directories per node. So we have SR Linux directory, we have COS directory, and we have some certificate directory that we use internally. In those directories, you will find configuration that, for instance, Arista uses and Nokia SR Linux uses to keep the startup configuration persistent. So that means that whenever you save your changes over the CLI, you will have them immediately available on your host machine. And that is very important because what you can do is that you can create a topology, you can dab your commands on the CLI, and then you can issue a command ContainerLab save, and it will save the configuration, the running config, to the startup across all the nodes that you have. It's like a bulk save command, so when you're ready, you save it, and it will persist on your disk. So next time you spin up a lab, you can continue from the point where you left. All right, now the lab that I will show you in a demo, the same lab with route reflection capabilities, that's exactly the thing that I did. I configured BGP on SR Linux, on COS, I created GoBGP YAML file so that everything is ready for you to see how it works. But then to make my SR Linux and COS node to boot with this configuration, I use a specific command, which is called startup config. That's in the topology example on the left-hand side. And I specify a path to that startup config. That's how easy it is to really make a topology that is already pre-configured for a certain use case. And then I packaged it, I pushed it to this GitHub repository, which you see on the top. And now the demo will be like you or somebody else pull it from this repository and see how we can build it. So there goes the demo. Let me. Will it run? Let's see. No, it's on YouTube. Okay, activate. I think that's the thing. Ah, no, maybe not. There must be like enable content or something.
I don't know. Do you have the link on
YouTube?
Yeah.
Yes, I can try. It's harder than it should.
We didn't do it on purpose.
You tell. Okay. Yep, we're back in the game. So I will start with the roots. We start with the installation. So on this containlab.srlinux.dev, we go to the installation tab. We copy this command, and we paste it to the node. This is just a VM, right? It has only Docker installed, nothing else. We paste this command over, and 3 seconds later, we will have ContainerLab installed. Now I go to this topology, to this GitHub repository where I have topology pushed. And I copy the repository URL, And I will clone this to this node where I just installed ContainerLab over. And this will get me to a repository, so I can open the directory. And let's explore what I have here. So I have the topology file, that's rr.clab.yaml. This topology file has 3 nodes, SR Linux, CUS, GoBGP. You see that I use startup config instruction to actually boot up with a predefined configuration that I created manually before. And I also use the images for SR Linux and CUS. So here I show that my current Docker image store has SR Linux and CUS images pre-pulled already. And now when I deploy this, ContainerLab will pull the missing image for the GoBGP part, because I didn't have it pulled before. And then it will start creating the lab. So the numbers on the left-hand side, it's actually seconds since the start time. So as you see, 37 seconds later, and that is because we're waiting on CUS to actually boot, we have this summary table. So now we have 3 nodes, CUS, GoBGP, SR Linux deployed. We have some IP addressing on these management interfaces. And I will connect to SR Linux CLI. You see right now I use the SSH connection, but I could use exec property. Now when I connect to the SR Linux CLI, what I will do is that I will watch if I received any routes yet, because that's the end game, right? We want to receive the route that GoBGP will inject. So I use this BGP neighbor, blah, 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 received routes, IPv4 address family, and SR Linux tells me there's nothing yet. It's like an empty table. I will install the watch over these commands, so the SR Linux will update me every 2 seconds if it has anything received from this peer. And now I will go to the GoBGP part. So on purpose, I didn't make GoBGP immediately send the route, because I wanted you to see how it works. So inside the GoBGP, there is a script, GoBGP shell, which calls a few scripts. First is configures the IP address on the Linux container, and then we start the GoBGP daemon, and we make the IPv4 announcement with the last part. It's all on the repo. It's like 5 lines of GoBGP commands, and that's it. So now we can execute this thing, and the way we do it is we use the Docker CLI here. We have Docker exec, container name, and we call this shell script. GoBGP starts, we wait 5 seconds for it to chill, and then we announce the IPv4 route. Now immediately when I switch back to SR Linux, I see that now my route is there. This 192.168.101 is already received from the CUS, so CUS reflected it to me. If I go to CUS right now, and I can do the same thing with SSH, I can SSH to the CUS container, admin's default credentials, so all good. I can use show IP BGP command here, and I see exactly that I have this route, 192.168.100. I received it from GoBGP, I reflected it back to SR Linux. So that is the ContainerLab in action. So now if I go back to presentation, oh, yeah, let me take the other slides right away. So I will start. So that was cool, right? But we do not only work with SR Linux and CUS. We have 9 different vendors, and across the vendors we have 15 different network operating systems. The breakdown between the containerized and virtual machine packaging is currently at 60-40 rate. So 60% of the supported vendor images are VM packaged. But you see that the number of network operating systems in container packages is really astounding. It's 40%, that's a lot. Across the board, we have these vendors already supported with different images. And you see here with these kind strings what we support. So for Juniper, CRPD, VMX, Arista, CUS, both container and VM based, XRV9K for Cisco, Sonic, FRR, and CVX from NVIDIA. Now, I will finish this off with saying that ContainerLab is not something that substitutes FNG. It is more like it's a different view on the networking labs. So if you are more on the DevOps side of things, if you work with Git, if you are familiar with Docker CLI, if you kind of like the idea of making your topology Git pushable, then ContainerLab might be a great fit for you. Also, if you work with containerized network operating systems, it probably must be the good fit for you. Because not only it has first-class support for containerized network operating systems, it also makes the data path really transparent. So you can have MC lags with LACP, everything is working, nothing is blocked, because it's just a VHH pair. And it's Git friendly. You push your images and your code, which is a topology, to Git, and you manage it with pull requests. You can review stuff. You can do all the nice stuff that you do with Git. That also makes the lab builds pretty much repeatable. You pull the image, you have your topology. There is no way it can go wrong. It will always boot with the expected configuration. The footprint is rather small, and you can deploy the labs really fast. Now, it's not everything is green and shiny, right? There are fewer traditional NASes that we support in Container Lab. Like in EVNG, you have probably 100 already, or whatever the number is. In Container Lab, we have just like the most critical ones supported. And there is no UI, so if you want to drag and drop, click and deploy, it's not something that we currently have. So if that sounds interesting, the way to do the next steps probably would be to explore the documentation side. It has a lot of things inside it. Container Lab is not just for 3 nodes topologies. You can build telemetry labs with Grafana and Telegraph and whatever, and they will be quite huge, and they will still be lightning fast to deploy. So you can try to create a lab with your network operating system of choice. If something is not right, or you want to propose an idea, GitHub issues or GitHub discussions is the way to go. And you can also join our Discord community. The link is in the documentation side. And yeah, if you liked it, give us a star on the repository. That would be really great. And with that, I finish. Thank you very much for listening. Taking questions?
Are there, yeah, thanks. I see there's one question. Go ahead.
Hello, Andre from RipeNCC. Thank you. It was a very interesting presentation. I wonder how open are actually those containers network operating system? For instance, can I just grab the image of the network operating system and redistribute it as a part of my product? Or is this problem? Does everybody have to download their own version of the container or something like that?
Well, if you have your network operating system in a container package, then Container Lab can work with that already. There is no integration effort really, so there is no proprietary containers or something like that.
You don't have to like agree to EULA to download it or something like that.
Sorry?
Like in end user license agreement, you don't have to agree.
Well, as a Container Lab user, you are responsible for images, so you need to bring your images with you, right? Container Lab comes without any images, so you have to have them on your machine or pull it from somewhere.
And do you know how hard it is to get them?
That's a great question. Yeah, so for example, like if you take Nokia for Linux, you can pull it just right now. There is no strings attached, no licensing, nothing. If there is Arista COS, for example, then you need to have an account with the Arista side, but it's free. So you just register, you pull the tar archive, and you load it. Some other systems might be more restrictive, so you might have to have a license, for instance, to use them. But so far, none of them really require it.
All right, thank you very much.
Yep.
There's also a question via IRC.
Yes, there is. So a question from Gordon. The question is, let me look. Containerized network operating systems, as far as you can tell, mostly contain the control plane of the NOS they're derived from. So do you have any recommendations or insights or pitfalls for modeling logical physical networks on a large scale? For example, testing a candidate config for an entire network and not just verifying that the generated config is correct.
Well, I think the containerized network operating systems, so that they are upcoming. It's not like you can have XRV, for instance, in a container. You would still need to use a VM. But if you work with containerized SR Linux or COS, you can have full feature parity with the virtual offering of the same system. So you can spin up a topology as big as you want, and you can test the data path, the control plane, the management plane, as much as the operating system supports.
I'll try to summarize the discussion we had on IRC just now about that, because some people remark that it's sometimes hard to model like switches with 48 or 96 or more ports in a virtual container.
Well, it's a limitation of the virtual image and not the tool.
I understand. Thanks.
Right. Thank you very much, Roman.
Thank you.
All right. Yeah, that brings us to Teun.
Which brings us to Melchior. Yeah. Melchior is not just hosting this event today, but he's also going to present to us.
I'll try.
He's going to try. It's a new presentation he hasn't given before, he told me, about, will it show up now? Yeah.
It's about demystifying quantum key distribution.
Yes.
Right, thank you.
Just
so
take it away.
There's lots of rumors, obviously, about quantum, what it can do, what it can't do. And I just was reading an article, or it came by in my LinkedIn feed about quantum AI. So that's even the next step, probably. But this presentation is really about what we can do with some of the interesting aspects of quantum and what is currently actually available. We'll first introduce some of the language. I have to say this is not a physics class, and I'm by far not a physicist, so I only try to understand it a little bit myself. But we'll talk about some of the terminology, some of the abbreviations, which are useful to know if you're interested in the subject and would like to explore further. I've added quite a few links on slides as well, so you can afterwards click on those and find more information there. Then we'll look on how we can use these quantum properties in a mechanism that is called quantum key distribution. And then we'll pull together how to use that QKD system with our current encryption technologies which are available. So let's start with what it's not. QKD is a mechanism that is used to distribute keys. It has nothing to do with generating the keys itself. That's one of the most common mistakes. So it's just distributing keys. The way the key is generated is, for QKD itself, out of scope. There's obviously generators, quantum random number generators, which are using a chip and a quantum processor, but QKD itself is just distribution. Also, you are not transporting any data using quantums or photons or whatever. The way we transport data in this mechanism is just as you're used to, right? So you're still using Ethernet and some encryption, MACsec, for example, IPsec, or any other technology. The only thing we use quantum for is to distribute the keys. So there's no quantum computers involved as well, right? You probably have seen some pictures or maybe things from, for example, the university here in Delft, where they have this whole setup with all the cooling equipment that is needed in order to run a quantum computer. Everything we're talking about here can be used at room temperature, right? So there's solutions already available, commercial solutions, for example, from Toshiba and ID Quantique and many others. And they are just working without all this high cooling. So it might still sound a bit spooky, but it's maybe not as spooky as you think. So let's first start with the problem statement. Why is QKD interesting and what problem does it solve, right? If we assume that at one point a quantum computer does become commercially available, the way quantum computers work, they can really easy, that's the expectation at least, factor prime numbers. And as you might know, the majority of our security mechanisms we currently know are based on prime numbers. Right? But the hardest part for a computer as we currently know it is obviously factoring those numbers. So multiplying prime numbers is relatively easy, but now try to factor it back to the original two numbers you used to construct the key. So again, the expectation is that a quantum computer would have much less issues with factoring those numbers. So every current key distribution mechanism or protocol as we know it that is based on those prime numbers will probably be vulnerable to quantum computers. The biggest question obviously is will we at one point see quantum computers that are so powerful? The way they do it is described as Shor's algorithm. It's an algorithm that is written for quantum computers to factor those numbers. Again, we're only touching the surface here because I see you have only 19 minutes left. So let's talk about some of the language that we're using in quantum. In our world, which is referred to by the physicists as classical networking, so we're all classics already, they use qubits, where we use bits, and a bit is either 0 or 1. In quantum, there's a qubit. And the aspect of a qubit is that it could be a 0 or a 1 or anything in between. But you only know if it's a 0 or a 1 or something in between if you measure it. And some of the really interesting aspects of a qubit, which makes it really interesting for security, is that you cannot copy it. As soon as you would copy the photon, in this case we're talking about photons, the quantum state will be lost. That is also one of the biggest challenges, because if you send a photon over fiber from Alice to Bob, and there is something in between that does regeneration or does something with the optical signal, the quantum state is lost. So that is also a challenge, because with current available solutions you cannot pass or cross any distance longer than around 120-ish kilometers. Some claim 180, depending on the quality of the fiber. So that is also a challenge. Another thing you might have heard about is superposition. And superposition is comparable to if you combine two audio waves of different frequencies, you would hear the sum of the frequencies. If you compare it to electricity, for example, there's 230 volts, but there's also 380 volts available in your shop or at your house or whatever. The 380 volts you get by phasing one 230 volt signal just a little bit different than the other one, and by adding them together you get 380 volts. That is sort of comparable to how superposition works. Again, the downside of superposition, a photon that is brought into superposition, is that if you transfer it over fiber with optical components in the path, you lose the quantum property, so you lose the superposition. Also, again, you cannot copy it as well. So teleportation, always referred to in some of our favorite movies, is that you could physically transport yourself to a different place. That's not true, unfortunately, and that won't be true anytime soon as well. What you can do is use teleportation to transport quantum states from one side to the other side. And the interesting thing here is that if you bring two photons really close together, then they can take over the properties of the other photon. So in other words, if you, as I mentioned, if you read or observe the photon on one side, it collapses its superposition into the 0 or 1. The same will happen on the other side. And that is the interesting part of what we're using to transport that data. Again, this is just really scratching the surface. So, as I mentioned, some of the advantages of using this quantum technology and qubits is that you cannot copy qubits, right? If you, what I just mentioned, if you would observe the state of one qubit, so let's say you try to interfere in the path and you observe the photon that was being sent to Bob, then the photon at Alice will collapse in the same state as well. So Alice will know that someone has observed the photon. Another advantage is that it's using physics over math. As I just explained, once quantum computers become available, it's expected to be much easier to factor prime numbers. What we just saw and discussed with quantum, you're not using math to distribute those keys to the other side, right? You're using physics, and so it's much harder to crack that, obviously. Some of the challenges, decoherence, for example, it's the current time that one of these photons that has been entangled with another one can keep the same state is still really short. So you cannot really store for a longer time a qubit. And that is one of the biggest challenges as well, for example, currently in quantum computing, that it's really hard to store those photons. That is why they have all these supercoolers, for example. But still, you can only store it, I think, currently at maximum of a couple of minutes. So it's only usable still for sort of real-time applications. Also, fidelity is a problem. Fidelity describes or is a number to express the chance that a photon that Alice has and that Bob has, and which are entangled, are different if you observe the state, right? You could sort of compare it to that there's errors in the path. So Alice observes that it's a 1, Bob observes that's a 0, right? And fidelity is good enough currently for some applications, like, for example, QKD. And scaling is an issue, right? If you, as I mentioned, maximum path is around somewhere between 100 and 180 kilometers. That would be interesting inside Amsterdam, for example, but transporting between Amsterdam and Düsseldorf or Paris or whatever could be a challenge. Also scaling in bringing this from point to point to point to multipoint doesn't work. You can only currently entangle 2 photons, right? It would be really interesting to entangle 3 photons, for example, for multipoint. So another thing that you probably have heard people mention is a quantum internet. So let's look at what is a quantum internet, or is it quantum networking? There is no quantum internet yet. Current quantum networking, as we just discovered, is just point-to-point, right? So it's 2 end nodes, which are able to, one will send a photon and the other has a detector that is able to read out the quantum state. That could be either over telecom fiber or free space using satellites. So there's a couple of commercial parties who are currently building solutions also based on satellites. So it's very comparable to point-to-point networking. As I mentioned, the issue with that is that it doesn't scale yet. So it's really not an internet yet. Current work is going on at, for example, TU Delft and other universities to overcome that that distance limitation by what they call entanglement swapping. As you can see in the middle, there's, for example, A and B. They can entangle 2 of these photons. B and C could do the same, and then you can swap the photons between at B. So A and C have entangled photons between them via a hop in the middle. Also, there's currently not really an OSI model as we know it in classical networking, but they're working on that as well. You might have seen the test TU Delft did with Cisco and KPN recently. Really interesting video on YouTube that sort of shows how this quantum network currently works, but again, it's just point-to-point. And as I mentioned, it's not always perfect quantum state, so the fidelity is somewhere between 0 and 1. For QKD, what we're now discussing, a fidelity of 0.8 is good enough. So the way we currently see these networks working is, if you look at the picture, all the blue nodes are just classical routers as we know it, but they will probably have in the future a separate plane that will take care of the quantum channels. So you will see either quantum information being sent over a different fiber, or in a CWDM, DWDM environment being in a separate channel. There is work going on where they try to send data over the same channel, but lots of that is still, as I think in marketing terms, or still marketing, it is in the end just using another channel on a CWDM or DWDM system. So there's no way yet to send both classical and quantum data over the same link, except by using CWDM or DWDM. So some of the possible applications for quantum could be clock synchronization, right? If you have a classical channel next to the quantum channel, you can distribute when exactly, for example, to make it really simple, you should read out the photon, and if they flip at the same time, then you can use that for synchronization. Obviously, communication between quantum computers, right, to send qubits between quantum computers and so share memory. In this case, we're using it for quantum key distribution. So let's look at how quantum key distribution works, right? We probably all sort of understand how symmetric key cryptography works. Alice and Bob want to share information. They don't want you to be able to intercept with that, so they agree upfront on a key that they will use to encrypt the packets they send in between. The biggest question here is symmetric key cryptography is quite secure, right? If you are aware that someone is able to intercept your messages or encrypt the key, you just increase the size of the key. The biggest question is, how do you transport the key to the other side? And that is where QKD can help. As I mentioned, why does that work? Because current public key cryptography is all based on mathematical challenges, right? Using prime numbers, for example. So RSA, Diffie-Hellman, and even post-quantum cryptography. QKD, as I mentioned, is relying on physics. So it's much harder to crack that, and as we've seen, you cannot copy this qubit, and if you try to intercept and observe the state of the photon, the other side will know. So a protocol was invented in order to use these quantum aspects to transport a key from Alice to Bob. It's called BB84, named after Bent and Brassard, who invented this protocol in 1984. So just to give you an idea how it works, Alice sends polarized photons from towards Bob, and these photons can be in, as we saw, different superpositions. In other words, she polarizes the photon, so it's either pointing upwards 45 degrees, 135 degrees, or 90 degrees. And she sends those photons over this quantum channel. Then they will do a measurement over those photons using a locally generated filter. And the filter is either a cross or a plus. So the plus will path the photons which are either in upward position or 90 degrees polarization. The cross will pass photons which are in 45 degrees or 135 degrees polarization. Bob will do the same. He generates a local filter and filters the photons. And so if you look at, for example, in the first example on Alice's side, you see the photon is pointing upwards, or the polarization is pointing upwards, the filter is a plus, so the measurement will pass the filter. The second is pointing at 45 degrees, but the filter is either 0 or 90 degrees, so it won't pass and you get an unexpected result. Now, if both Alice and Bob exchange their filters, you see that in some cases they will have used the same filter. In other words, the first measurement will actually create a 1, the second will fail, the third measurement will proceed as well. So now if you sift through the results, you will see that the outcome of the measurement on both sides is 0, 1, 0, 1. And obviously the result is then that the key in this case is 0, 1, 0, 1. Really short again how this works. But by doing this, and for example, if now someone would try to intercept this communication, you obviously, as it's using both a quantum channel and a data channel, if you intercept the quantum channel, then you might see the photons and you can apply your own filters, but you don't know which filters Bob has generated. and Bob and Alice exchange those filters via a public data channel. You would need to intercept both channels, but by, as we mentioned, the properties of a qubit, that it collapses. It would be really hard for an interceptor to regenerate the same qubit and send that to Bob. That is why this is considered to be really hard to crack. Now let's see how we can use that in routers, right? Again, we have Alice and Bob, and Alice and Bob have a encrypted channel in between. As I mentioned, could be MACsec or IPsec or any other protocol to secure or maybe authenticate a routing protocol. And now they will start using this quantum, a QKD system, quantum key distribution system to communicate on the key. So in this case, Alice and Bob, and we have obviously our friend Eve, who tries to intercept in the conversation. So both Alice and Bob have a QKD device. Alice is the sender of the photons, and Bob has a photon detector reading out those quantum states. Both also have a router at their side. And now this is in basic how it works. There's 3 channels in between, a quantum and a data channel between the QKD boxes, and an encrypted data link between the 2 routers. Now Alice requests a key from the QKD device using an interface, which is a REST API that is defined by Etsy. So she sends a key request to the QKD device. Obviously, she gets a key back and a key ID. Now, the only thing Alice, the router on Alice's side, has to communicate to Bob is the key ID over the data channel. And Bob can use that key ID to request a key from his own QKD device. And obviously, in ideal situation, he gets the same key back, and they can use that to encrypt the communication. So where is this applicable? As I mentioned, most QKD vendors expose a REST API, which is defined by Etsy. So you can just request those keys via this REST API and use it in many symmetric key algorithms and protocols, right? It could be, for example, MACsec or IPsec, or authentication of routing protocols using TCP/AO. The thing is, you need a mechanism that allows for key rollover, obviously, right? And the thing is, or the interesting property is that they can generate these keys at pretty high speed, so you could potentially do a key rollover, for example, every minute. But yeah, then your protocol needs to allow for hitless key rollover, otherwise your communication will be interrupted every minute. So that is what is currently available. I don't think we're there yet. I don't think this is, as it currently is, really interesting because of the limitations. So there's quite some work still to do. I've put a few bullet points up here. So I think the biggest point is obviously the distance limitation, but also that it is only usable point-to-point. Now, what if you have, for example, small point-of-sale offices, remote workers, etc., who would want to use those keys, but you do not want to put around 100K euro photon detector at your house, for example, right? And you don't have a satellite on the roof, etc. So how are you going to distribute those keys, which via non-quantum channel, but quantum safe? So there's a lot of challenges still. If you're interested in the subject, you might have seen a few links on the slides. Here's some further reading as well. There's quite some work going on in IETF. There's quite a lot of work being done by universities, especially a university in Delft. And are there questions? Is this interesting? Is it applicable? Will we ever see quantum computers? Much still unknown. But I think it's a fascinating subject.
Well, the way I see it, there could be no questions, or there could be one question, or there could be anything in between. But the moment we ask how many questions there are... So, any questions?
Well, there is one question from the audience, from online. It's from Battery Bear, and the question is if you can comment on the NSA paper that says NSA does not consider QKD a practical security solution for protecting national security information.
Sorry, one more time, which paper?
It's an NSA paper that says NSA does not consider QKD a practical security solution for protecting national security information.
It's interesting fact that the NSA is saying that, right? Because as we saw, it's really hard to intercept key distribution using physics. So I can see why some state actors are not really interested in using this or seeing this widely deployed, because it could make their job quite hard.
Yeah, that's not practical.
Any other questions?
Is that another question from you, Robin? Yeah?
Yes, hello. What are the practical uses that would require quantum key distribution? There's a lot of crypto going on, from banking to Bitcoin. Where would QKD be useful first? And will something like this be necessary for all crypto in the future?
It is practical if you are very worried about distributing keys, obviously. So if you, as you mentioned, a main interest is, for example, from financials, financial companies, trading companies, high-speed trading as well. If it is, but as I mentioned, I don't think it is practical enough yet that it is really usable, right? You have to imagine this is at a stage where we were with the internet 30, 40 years ago, where you could send a few characters and then it would crash the system. That is where I really see this is now, right? Many of the things, especially in the field of quantum computing, are still research projects, right? So it works under very specific circumstances in a lab in the university. But even, as I mentioned, they can preserve a qubit for maybe a few minutes, right? So that's far from practical. So this is really early stage, but I think the promise is really interesting, especially if we see quantum computers becoming more powerful. Because if we come to a certain point where potentially a quantum computer could crack our current security mechanisms, then you want to know how this works and want to start using this, obviously. But we're not there yet. We're still safe for at least the next 5 to 10 years. So that's the good part.
And for general purpose, like HTTPS, TLS, will something like this be necessary?
Could be, yeah. They are vulnerable to quantum computers, yeah, definitely.
Okay, thank you.
All right.
All right, thank you, Melchior, for your kind presentation. That brings us to another coffee break. Same rules apply, please. One side go out there, one side go out there. Once you get downstairs, there is something different. We had a number of t-shirts left from previous years. So at the exact same spot where you got your red shirt today, you can now also get blue, white, or green ones to complement your collection. Please be back in 45 minutes. Right, is everybody back and refreshed? It looks like the room is getting a little bit emptier, but there's probably more people joining us online now, so that's probably very good. The next speaker is a little bit of a curiosity for today, but also for the regular NLNOG program, because we are very honored to have with us today virtually Ron Roosendaal from the Ministry of, well, here we go, Volksgezondheid, Welzijn en Sport. Yeah, how do we do that? So public health, another well-being thing, and sport. And he works there, and he has done a lot of work on the Corona Check app that, well, we have used this morning actually here. And he is going to tell us about it. Now, the thing is that usually we have a wonderful video system that we can get people to call in, and that works. But the easy part, changing the slides, doesn't. So I'll be playing Ron's remote clicker and hope that I catch up on the slides. And I'm sure that this will be an interesting presentation that lots of you will have questions for. So I would say in a second or three, we should start with Ron Roosendaal from the Ministry of Volksgezondheid, Welzijn en Sport.
Good afternoon to you all on-premise and online. It's good to be with you, and it's a bit strange. I'm looking at a device and I don't see any one of you, so I hope it works. I'd love to be there, but I couldn't. And I'll talk you through what we do on having the Corona Check app that you all use to enter the premise, I understood. But for that, I'd like to introduce myself. I'm Ron, I'm CEO and Director of Information Policy at the Ministry. And I'll talk you through what we do to, in a relatively open way, support the apps and all the things to do to get out of the pandemic we are in. I hope you see slides. I don't see any slides at all. So can I have the second slide, please? And I understand from people around here that, oh, thanks a lot for that, that the volume is a bit low. So if you can pump that up, it'll be great. But we'll talk you through that. It all started with the Dutch contact tracing app, the app called Corona Melder that started in the beginning last year with a large event in a weekend, over a weekend. We called that an appathon, and that was evaluating apps on the market for contact tracing. And the results, so the summary of the weekend were that there were many apps already in place in several countries in Europe, for example, but none of them was far enough to introduce in the Netherlands. And from that on, we decided we are going to do that ourselves. We, the government, with a lot of people from outside. Next slide, please. And we did so, and we do so in a relatively open way and with the best and the brightest. So we asked people from outside, are you willing to help? And are you willing to help us to fight the pandemic? Next slide, please. In a relatively open way, our minister was the first to push a Git commit to publish one of the websites, for example. And we did so in a relatively open way, added even the icon of Corona Melder. There were several alternatives put online, and people were able to choose the one they preferred. And that way, the actual icon of Corona Melder was influenced by designs and input from outside. Next slide, please. And radically open is the term that describes all of what we do. For example, there is a continuous scientific research going on why people use apps, the things we produce, how they use them, and if we can improve them based on research. So there's research into how people used it. There is research into the epidemic, the effect on the epidemic. And so there's continuous research and everything we do on Corona Melder, but also on Corona Check, and even mystery guests on Corona Check. You might be having a mystery guest next to you, because events that use Corona Check, we send mystery guests to do research into how the app is used, and if for example, people are checked at the door as they should be. Next slide, please. Radically open also is in effect as to how we do security. For example, all the pen we do is published online at the government site. The pen test itself is standardized in a radically new way, so that all pen testing we do can be compared and is standardized. And you can find those pen test reports online. And even the first pen test is published, so there is no rework done before publishing the results of a pen test. Next slide, please. We even go so far that you can verify that the app in the App Store is the same app as published. So there is a declaration that every time we publish an app, that is the same code as is available online on the GitHub of the ministry. Next slide, please. Which is true for how we ask the community to cooperate in how we develop all the things we develop. For example, the bug bounty of Corona Melder. And next slide, please. Also the results of using that app. So these are the results of a Melder. That is how many people testing after getting a notification with or without complaints proved to be positive on COVID-19 or the coronavirus. So on the website coronamelder.nl, you can follow the scientific results week by week and see if it works or does not work. Next slide. So what are the main different ways we now work compared to how government normally works? First of all, I have the honor to work with people that we normally cannot work with. They wouldn't work for us, the government. If you look into who work with on the Corona Check project, you, for example, will see a lot of members from Hack 42. People that work 60 hours a week, completely open, but support the government in fighting the pandemic. And why do they join, or why do they stay? Next slide. By cutting the crap the government normally introduces, lots of talk, less doing. And next slide. By cutting hierarchy, by not having to get the other people above you to grant you the permission to continue, but by having people do what they're good at without bothering them with hierarchy. Next slide. By aiming for the highest in everything we do. For example, next slide. In privacy, we aim for the highest. I'll come into that when I'm discussing Corona Check later on. Next slide, please. In accessibility, everything we do is accessible to the max for people that are blind, for people that are handicapped, etc. For the apps, the websites, etc. There is no concession as to privacy, and there is no concession as to accessibility. Next slide, please. There also is no concession as to how open we work. Everything we do is published on GitHub. So now I'll enter the realm of Corona Check. Next slide, please. Corona Check was not started for the digital Corona certificate that the EU introduced. It was started for domestic certificates, where at the end of last year, Dutch scientists advised us to come to a certificate that proves that the chance you have the virus is at a minimum level before entering events. And the Netherlands, and most of you will know that, introduced a law to support that, that way of working. Next slide, please. And what if you design such a system from the bottom up? First of all, you would want privacy and security by design. So there is no central registration. There is only one place where your QR code is, and that's in the app. But you would also not want people to be linkable, traveling from one pub to the other or from one event to the other. So new QR codes are generated every few minutes and even faster from now on. But that, of course, is not possible on paper, but that's possible in the app. And you will want to balance fraud prevention and privacy. For example, having had a test is a delicate medical information. So you would not want everyone at a bar to be able to know exactly who you are and to get a database of all of that. And then you would want the utmost as to accessibility. You would want it to be usable for the majority of the Dutch population, including these people without mobile devices. And you would want a offline use also. And thirdly, we want it to be open, completely transparent, usable for everyone, and verification possible for everyone. Next slide, please. And the last two, you would want, and there is a kill switch. There is a kill switch in Corona Melder and there is a kill switch in Corona Check. And from that moment on, it won't work. So the government can stop it at once. And you will want to prevent abuse. Can I have the next slide, please? So in the domestic QR, and if you are on premise, that's the one you showed. These are the data that's in it. The first letter of your surname and your forename and the day and month of birth. It might even be less. If your first letter of surname and forename are not that free, one of them may be left out. So the only information you show at the bar is your initials and in your day and month of birth. And that's the way we balance fraud prevention and privacy. Next slide, please. But then the EU decided to come up with the digital Corona certificate to facilitate a cross-border use to return to free movement and to make that interoperable with worldwide initiatives. And as the EU did that the first in the world, it'll probably be the way that other countries will work too. Next slide, please. And the EU decided to make it digital and paper-based, as we did in the Netherlands, with an interoperable barcode, information in readable form also, and with a trust framework. But the point is, each member state verifies against their own business rules. So each member state has to have the data itself. Next slide, please. So the difference between on the right, the domestic QR code I showed you before, and that was designed with privacy in mind, completely in mind, compares to the 3 different data sets you can show in a DCC in this way. There is a lot of data in the DCC because every member state will have to have that data to validate their own business rules. Next slide, please. So that in Corona Check, you all used the Holder app, the Corona Check app itself, in which you can store both the domestic QR code and the international codes. There is a scanner for events, for domestic events, the Corona Check Scanner app, and the Ministry of Infrastructure designed their own app, which is the DCC scanner that scans the international QR code that has all the data in it. Next slide, please. And that is what we then designed. People get tested, they download the app, they retrieve a negative test certificate, and later on we introduced also recovery certificates and vaccination certificate. The app itself generates a certificate that now not shows what the source is, so the QR code that you all used to get into the event does not show if you're vaccinated, if you are recovered from COVID-19, or you had a negative test, but it only shows that you are safe to enter. And on the verifier side, you would download the Corona Check Scanner app, and everyone can download that app, and then you start scanning. So you get access with either a negative test or a recovery or a vaccination, and the people at the door will not know what the source of that was. Next slide, please. And in the visual example, but you all have the app, I guess, this is how it works. Next slide, please. So for the domestic QR code, at the door, you will only see that you were valid to enter. Next slide, please. So either you have a valid code or the code is not valid, and there may be many reasons for that. For example, it is too old. Next slide. And on the DCC side, if you show the European QR, there is a lot of data in it, your full name, your birth date, etc. And the reason for that is that at the border, the country of entrance can validate against the own business rules, so they have to have that data. Next slide, please. The portfolio all those people work on is not those two apps only. We have Corona Check, the app, we have the Corona Check Scanner, but then coronacheck.nl also is a print portal. So it's the web version of the Corona Check app on which you can generate your QR codes on PDF. But there are many people working in healthcare that have to be able to provide a QR code on paper for those people whose data cannot be found by the app. So we developed a separate website, including all of the methods to identify healthcare professionals and to safely hand out access codes to be able to, for those people to generate a QR code on paper. This is not a simple website. There's a lot of work behind that. We also developed a viewing and staging area for all of the RIVM data, the Dutch professionals that where the vaccination data for scientific research and is stored, and we helped them building a database for that. We also developed the backend signing services for the Netherlands, but also Curaçao, Sint Maarten, and Aruba that sign the QR codes to be able to check for other member states in the EU that those QR codes are valid. We have a interactive voice response system for people that are not having a computer, and they can enter their citizen number, and they'll get their QR code on paper via snail mail. So we also developed printing and sending that QR codes via snail mail. We have to manage a lot of connected labs, many more than just a few, dozens of those. We have 24/7 monitoring, red teaming, and security operations to monitor that system. And we have people working on the international relations and the standardization work within and outside the EU. Next slide, please. My main, and some of you will actually know what this stands for. My main takeoff of my main, what I learned from the past a year and a half is that within government, you normally would ask the market, ask companies to produce stuff like this. And you only can do that if you actually precisely know what you do. So the block of Bert Hubert on the toaster is my main takeoff, all that work. Thanks. That was the end of what I wanted to say. Ik hoor helemaal niks. Het is heel gek. Het is echt heel raar praten dit. Ik zie helemaal niks.
You might notice the lack of a network engineer anywhere on this slide except for the note that says I'm not one. The last time I touched a network device CLI might have been 10 years ago, and that was during a lab at school. However, fortunately, the company I work for, PowerDNS, we do a lot of business with mostly access providers, and sometimes it's not a DNS problem when we're debugging things. So we know also some things about the networks. And at PowerDNS, I do like a bunch of things. One of them is the configuration management. So in the system administration world, there is a very, very big movement towards configuration management, automation, etc. And for me, this sentence is at the core of this. No one is or should be touching a system shell ever. Like if somebody logs in via SSH, runs a few commands, you have to shred the whole machine and reset it up because it's in an unknown state. This has been going on for years. There's a lot of different systems. In 1993 at CF Engine, which still exists and is in use, and new paradigms have been created, new software has been created as well. So I will mostly be discussing configuration management systems, at least the part of it. I won't be discussing orchestrators or Kubernetes or containers or what have you. It's going to be a very old school kind of thing. So also no infrastructure as a service, etc., etc. So many of these configuration management systems have certain properties. Not all of them have the same properties, but many of them are declarative, which means that the configuration that you put in for your systems is not a series of separate steps or commands to follow to get to a certain state, but it's usually a you declare that the state of a certain package has to be installed instead of you typing, please run apt-get install my package. There's idempotency, which means that once you have declared the state, if you push the same state to the system, and the system is already in that state, no change happens, no commands get run to maybe get into that state again. Some of them are convergent, which means that you can declare the state, send the state to the device, and then the device will get into that state in a few steps. Might not be immediately. And one of the most important things is the modularity or code reusability, where you can share certain modules for installing certain things. So if you, we have Ansible modules for PowerDNS that we distribute, and it's easy for anybody to just download these modules, use them, and also contribute back, because they're on GitHub as well. From what I gathered from the documentation of these systems, when you want to apply these kinds of techniques to network devices, many of them seem to be very fancy CLI wrappers. They're also not truly declarative. Things I've seen, okay, for instance, Ansible has a Cisco module. Yeah, it works, but you do have to tell Ansible what type of Cisco you have. And if you want to bring it to a certain state, you have to put the CLI commands in the right order to get there. Some things have been then declarative within Ansible. I think you can do some very basic port things like, okay, I know this port and it has to have these properties, then that works. But if you want to do something a little bit more out there, good luck, you know how the CLI works. And many of the paradigms don't actually match. There is no system or Unix system that has a candidate data store or allows you to do proper configuration transactions where you could say, okay, please apply this configuration now. No, it's not good, roll back. There is no true way of doing that properly. So why would you actually want to use Yang and netconf? So who here knows about Yang and netconf? All right, excellent. So this is layman's is maybe bad. I have done some experiments with these configuration management systems, and then later Yang and netconf for a project. So I'm looking at it from a systems engineering and mostly non-network person glasses. So from what I can see is that many, actually all vendors have separate or different CLIs on their devices, which is fine. Many of them also provide configuration APIs. And these configuration APIs, of course, differ between vendors, but at least they have an API. Then there is the SNMP, the Simple Network Management Protocol, which is neither simple nor a true management protocol. And it has a fair share of drawbacks, as you may know. One of them is it's very stateless. It uses UDP as well as for its communication. And when you want to do configuration with it, you have to put all the information in the message that you send. There is no way to tell the device, please just change this little thing. Also, the MIBs that are being used are very, very non-standardized. Each device and each vendor has their own MIBs, and there's very little commonality between them. And then there's the lack of read-write objects in many MIBs. It's a lot read-only, so it's mostly a way to read information from the device and not actually configure the device. And we're not going to talk about security of older SNMP versions here. So a couple of years ago, I think this is from 2002, in RFC 3535. I can highly recommend people reading this RFC. It is called Overview of the 2002 Internet Architecture Board Network Management Workshop. In section 3, they have the operator requirements, where the IEB describes what needs to happen or what properties a proper network management solution should have. And it all boils down to automation should be easy, and things that are common between vendors and devices should also have the same schema and be common. And this is where Yang and NetConf come from. And so these authors are, of course, a little bit biased because their book is called Network Programming with Yang. However, this chapter heading, CLI is no longer the norm. If a feature cannot be automated, it doesn't exist, rings, I hope, true for many of you. It at least does in the system administration world, and I would gather it also in the networking world, because you might have even more devices. So the IETF created the solution known as NetConf, which is a configuration manipulation protocol, and Yang, which is the modeling language for the data in there. They wrote a ton of RFCs. These are just a few of the first. They're still writing RFCs, although the Yang language itself has been at version 1.1 for, well, almost 5 years now. Well, yeah, 5 years now. So that actually means it is either nobody's using it, or it's good enough and everybody is happy with it. Fortunately, it is, at least from what I read online, it's the latter. So how does NetConf work in short? It is, of course, a nice layered protocol. You have a secure transport layer, which is defined in the RFCs as that it must have a crypto component. So it goes over SSH or TLS. On top of that, you have the different messages that can pass between a server and a client. Then you have the operations, which are partly modeled. And then you have the content, that is the configuration data, the state data, or any other data. That is fully modeled with the Yang language, that I'll get into later as well. There is, apart from NetConf, a different protocol. It's called RESTConf. Some of you might also know it. This maps this whole architecture on top of URI paths and a RESTful interface using HTTP semantics. So if you look at the full picture, on top you have Yang as a modeling language. Then you have the data models created in Yang. Because Yang is just a modeling language, you can encode or serialize the data in a bunch of formats. XML being the first one defined. There's also JSON for those who get bumps when they read the word XML. And of course, protobuf and actually any structured data representation you can use. And as JSON is also YAML is also a superset of JSON. You can also do this in YAML if you really, really love YAML that much. Then there's the protocol that actually carries this data from the server to the client. And then there's a bunch of applications like orchestrators, development kits, Open Daylight, which is also a NetConf server, etc., etc. And those can be written in any language, just as long as you can read and write the NetConf protocol. So, bunch of protocol features. You have CRUD operations for your configuration. Because of the modeling, everything is fully declarative, so there is no reason anymore to do actually some imperative command line programming. There's a difference between configuration and operational state. So you know based on the model or the things that you're doing that, okay, I can change this, or hey, this is just state, like the port is actually up or there's something connected. It provides network-wide transactions, which have a bunch of ACID properties. So you could start a transaction to create a VPN through your whole network using multiple hops. And if one of the devices has an error during the application of the configuration, it will all be rolled back because there's a two-phase commit that you can apply over the whole network. Of course, there's rollback support. And the nice thing is netconf is just one protocol that you can implement in all controllers, devices, orchestrators, etc., without the need to have any deviation or different kinds of protocols for the configuration of multiple devices. And because of many of the models have been standardized, the inner workings of the device are somewhat invisible, meaning that you can pretty quickly switch between vendors or other different devices that have very similar properties. So what actually speaks netconf nowadays? Network devices, I listed a few vendors that I quickly on their website could find that they supported. Cisco seems to be all in. They have on their dev days a bunch of presentations as well on netconf, and they seem pretty happy with it. Like I said, I'm not a networking guy, so I assume they are. A bunch of orchestration frameworks, some network management systems, and there's even configuration management software like Ansible and Puppet that have netconf modules. Some of them without actually the modeling, so you will have to do raw netconf messages, but it exists. Also, Yang and netconf are part of the ETSI, NFV, and American MANO standards for network function virtualization. So Yang, for those who don't know, stands for yet another next generation, which tells you something about how often we've tried. So the language, it is quite human readable. It has many built-in types. It has different integers, all kinds of. It has booleans, like anything you could reasonably expect from a programming language or a data definition language. It has it. The types are reusable. So here on the right side, you see that I create something that's called an endpoint. I give it a description. And then I have what's called a leaf, because everything in Yang is a hierarchical tree structure. And it's called IP address, and it uses the type INET IP address no zone. And that is something that the IETF defined. So it is a IPv6 or IPv4 address without any zone information attached to it. And it is mandatory to set in this type called endpoint. And there's a port, which is a port number, and that is defined as a uint, what's it, I think 16, yeah, 16. Then you can do derived types. So I could even create a type that says, well, I'm actually IP address no zone, but I'm going to restrict it to the first octet being 100. That's even possible. You can do data constraints, like the mandatory, if I have a value here, it must match a value in a different part of the tree in this model. It's modular, so you can just create different modules that can be imported by other modules. And it's versioned, because when you do an import, you actually must import from a versioned Yang model. So when you have a module, for instance, like I said, it's hierarchical. I create a container called listen addresses. It has a list, which is called listen address. When I was working on creating models, I realized that you have to flip your brain a little bit, because the listen address, singular, is a list. You call listen address, but you must name it singular, because every item is called a listen address. And also, a list in Yang is actually what we would call a map or a hash map. So it has a key and a value. So here the key is name, which is a string. Then there's IP address and port, which has the constraint that within this list has to be unique. So I can not create something with a different name and the same IP address port combination. And it uses the endpoint that I defined on my previous slide, and I refine it a bit. If it's unset, it will default to 25. So this is another nice thing about the modeling that you can do. Then there's of course the state data or operational data, which here is marked as config false. So you cannot set it; you can only retrieve it. I have a thing called the connection count, and it is a uint 32. So when you look at the hierarchy of this whole module, it's very short, but this is how it looks. So there's a read-write thing called listen addresses. Then within there is a read-write thing called a listen address, and there are 0 or more of them, and they're keyed by name. Well, then you see what goes in there, and then there's a read-only thing called counters, and in there is a connection count, which is also optional. So the reuse of all these modules, there are the IETF alongside the OpenConfig project, the Etsy, the Broadband Forum, and a bunch of vendors are creating a lot of modules. For instance, for interface types, for IP addresses, for full TLS server and client configuration, including X509 certificates, SSH server and client configuration. And it's used by many vendors to model their devices. So once you have a bunch of vendors doing this, the models actually look similar enough for you to quickly understand what's going on. And they're all published on GitHub as well. So now we come to how would you use this in a systems engineering environment. So this is a straight up copy or a screenshot from one of the RFCs. There is a netconf engine running on the netconf server, which would be, in our case, a Unix server. It has all the data, so it has the configuration data, the state data, notifications, operations, etc., based on the Yang modules. And underneath there's just the software components that you can control using netconf. So does any of this actually make sense for a system management operation? And when you think about it, it could. Many applications could be what is known as a network function within the NFV space. So if you would have a DHCP server that actually runs on a Ubuntu system, it could be a network function, especially if your core business is networking and not system administration. You can just model or have a model of a DHCP server, spin up a Ubuntu VM with the right software, and configure it via your NMS. With the right orchestrator, you can have all your infra, of course, versioned. This comes very close to what most of us are doing with Ansible for our systems. And even without netconf, Yang is actually a very powerful data modeling language that you could use for configuration or defining your configuration of your daemons. And if you're already using Yang and netconf, it is even better because you don't have to learn anything new. And we know that especially the older people hate learning anything new. Maybe a fun observation from what I gathered, many of the telcos that I deal with have very little with configuration management. We've deployed very big DNS infrastructures where the department was like, sorry, what is this Ansible thing you're talking about? And this was 3 or 4 years ago. So it's, if they have something, they don't like to switch. So there is a bunch of software for Unix-like systems. There is libyang, sysrepo, netappear2. These all work together. So the first one is a Yang parser and toolkit. The second one implements the Yang data store. This includes the configuration database, the candidate database, etc., does all the transactions. There's netappear2 that uses the other two pieces of software to implement a netconf server. They're written and maintained by SESnet, which is the NREN of the Czech Republic, so like the SurfNet of the Czech Republic. It's written in C, and many of these pieces of software have wrappers for other languages. So this is a bit of an architecture of sysrepo. So there's the network management system, has the models, talks netconf. Then there's netappear that is installed on the system. It exposes an SSH port. for communication, then does some IPC to the data store, and then that IPC that sends IPC to any of the plugins, because sysrepo is a plugin-based system where plugins can claim part of the whole tree within the Yang data store, either on a callback mechanism. So if something happens in this part of the tree, do send me please call this function, and then I will provide you with the data or the things you need, or the other way around. I claim this part of the tree and I will update the data in the data store if needed. So does this work? So I've done a project for this. And the answer is yes-ish. So there is the ISC Kia DHCP server that is fully modeled with Yang and uses netconf for configuration via Netoppeer. And it's in production in a countrywide ISP that has their whole network modeled on Yang and even deploys all the modem configuration of the end users using netconf and Yang. Many plugins exist for sysrepo. However, the C API is very C, which, yeah, it's not for me. Also, because this is written by the NREN, the software is also a bit academic, but much to their credit, if you make a bug report, ask a question, they are very fast with answering, helping you, etc. But it is a piece of software that requires a lot of head desking at places. Also, there's the versions of sysrepo that are released, which is 0.7, 1.0, and recently 2.0, are incompatible with each other. So if you have a device, or if you want to install sysrepo but don't have a plugin for 2.0, but only 1.0, it probably won't work. So you cannot do all the plugins on the same machine. No OS has packaged any of these pieces of software, probably because of the state and flux they're in. And in older versions, badly written plugins could crash the whole sysrepo process, meaning that you have no configuration management at all. So, in conclusion, from what I gathered online as a non-network engineer, is that Yang and netconf are becoming the industry standard for configuration. Many of the concepts map well to system configuration management and would even be very cool. I would really love it to have a system where I could have a candidate data store or the difference between the running and the startup config, so I can see what actually happened on that system. But right now, the software is not truly production ready, but I do encourage you to have a look at it if you feel very brave. So thank you very much. And if you have any questions, then please come to the front.
Thank you, Peter, and apologies for the introduction. We were a bit out of sync on who would do what. So
that's okay. I hope I did well myself.
Absolutely.
Good.
Sander, you have a question.
Hello?
Oh,
there we are.
There he is.
So the things you mentioned about netconf and Yang, especially netconf, like two-phase commit, candidate configurations, all that kind of stuff. I wish that had actually been a mandatory part of the protocol, because I've seen too many network devices that don't have a candidate configuration, that don't have two-phase commit support. So while it's possible in the protocol, in the networking side. I mean, Melchior is standing there. I can fully confirm that Juniper does it the right way. But I've had other network devices where, it just wasn't as usable.
From what I gathered from the RFCs, there's I think the NDMA RFC, which defines which data stores must be defined. I believe many of the data stores and the transaction stuff is mandatory when you want to implement that, and I believe it's a part of the core right now.
Okay, that would be good, because I was just looking stuff up for a certain type of Cisco, and it was like, you can have a candidate data store. You just have to configure it manually first using the CLI.
Well, it's something.
Thanks, Subner. Roman, you had a question.
Yeah, thanks, Peter. So I reminded myself that 2 years ago, I saw a presentation of yours from Config Management Group, where you said that you created this netconf wrapper for the Power DNS configuration. And I was quoting your presentation saying that it's great to use Yang outside of networking domain to configure stuff on the Unix systems. 2 years have passed. I never seen anyone doing that. Why do you think that is?
Why nobody's using Yang as a language to model their
Not
configuration?
Yang, well, Yang plus netconf for doing anything outside of networking domain.
I don't know. It might be that network engineers and system engineers just don't talk that much to each other or live in such different realms. On the other hand, it might just be that netconf and Yang, it's relatively esoteric, especially when you when the bash or whatever shell you have on your Unix system is so powerful with all the different tooling that most of the network devices, I mean, they have a bunch of powerful stuff, but it doesn't have the general purpose-ness of a Unix system. It might be that. I honestly don't know why people don't use it.
Thanks.
There are also a couple of questions via IRC came in.
Yeah. It's a two-part question from Jeroen, which is, how many devices support this? And by this he means netconf and Yang. And the second part of his question is, what about all devices?
The first part, I don't know. I would think a lot, based on the marketing materials I've seen on the vendors' websites. I mean, there are people who know this probably in the room. And sorry, what was the second question?
What about old devices?
I'm pretty sure they don't have this.
Okay, thanks.
Okay.
All right, Peter, thank you very much.
All right, you're welcome.
All right, up next is another remote speaker, and I understood that you could hear our little conversation a little bit there behind the curtain. I think Melchior and myself just lost a couple of years of our lives there, back there. Anyway, you have these segment routing networks these days, you know, so you put packet headers that indicate exactly how the packet is supposed to go through the network. And that's obviously wonderful stuff, segment routing. But how do you do multicast in that environment? Well, here to tell us today, in 3 seconds from now, is Jeffrey Zhang from Juniper Networks.
Good afternoon, everyone. My name is Jeffrey Zhang. Today, we are going to talk about multicast in segment routing networks. With segment routing being deployed or considered by more and more operators, those with a multicast requirement may want to consider what options they have to do multicast in a segment routing network. And so who may have a multicast requirement? Multicast is for distributing information from a single source to multiple receivers. It has been used for a long time for many use cases, including IPTV, video distribution, financial data distribution, and some enterprise may use it internally for multi-point delivery. Multicast will also become more important with more and more real-time, large-scale distribution of high data rate content. A classic example is the World Cup soccer games, things like that. So today we're going to talk about segment routing principles and corresponding multicast options. We will talk about controller signaled P2P tunnels. We'll talk about BGP signal multicast, end-to-end inter-region multicast, and finally, if we have time, we'll talk about multicast with transport, with class 4 transport. A quick background on multicast technologies. First, we have IP multicast. An IP multicast flow is identified by a source group address pair. is forwarded along a tree that is typically set up by pin protocol, and that tree is specifically for that source group flow. And then we have multicast tunnels. A single tunnel can be used to transport many multicast flows through part of a network. The tunnel could be an IP multicast tree itself. It could be a RSVP TE P2B tunnel or MLDP P2B tunnel. It could be ingress replication or the latest beer tunnel, which we'll talk about briefly. And then there is MVPN, basically multicasting a VPN. How do you transport customer multicast traffic over a provider network? There's Rosen MVPN and BGP MVPN. It involves PE2P signaling of customer multicast state, basically which PE needs to receive multicast traffic, and also PE2P forwarding of the customer multicast traffic via the tunnels. So principles of segment routing. The way I see it, there are two. The number one principle is that we no longer have per flow or per tunnel state inside the network anymore. The packets themselves have embedded segment lists for traffic steering across the network. The second principle is optional but preferred use of controllers. The controllers are used to instruct ingress node to embed that segment list in packets so that it can be used for traffic steering. Now, when you look at the SR principle number one, no per tree state inside network. To do that, there are two ways. One is the ingress replication. Basically, the ingress router will send individual copies to egress routers, and the transit routers have no idea that it is multicast traffic. The second one is beer. With beer, the packets will carry a bit string. Each bit in that bit string indicates a particular edge router that needs to receive traffic. And the transit routers will look at that bit string and figure out which next router the traffic should be forwarded to. If the beer gives efficient replication across the network, just like the traditional pin multicast tree or MLDP tunnel, but unlike those, beer does not require per tree state inside the network anymore. Technology-wise, beer is the best technology. It's relatively new, but it requires a new forwarding plane, so its deployment has not been ideal. So in today's presentation, we'll actually not cover beer. We'll talk about cover other multicast topics. I want to point out that both ingress replication and beer, they stick to the SR principles. However, they are actually independent of SR. Even without SR, they can still work. The next principle is the use of controllers. When it comes to multicast, there are two ways to do that. The first one is that the controller calculates a P2P tree, and then the result of that calculation is sent to the tunnel ingress, and the tunnel ingress will then use the existing RSVP TE P2P tunnel to set up that tunnel. We actually have an implementation and actually deployed in production network in a European tier 1 provider. The next one is that not only the tree is calculated by the controller, it's actually signaled from the controller directly to the tree nodes as well. This include the SRP2MP, or also known as tree SID, It can also be MLDB tunnel that is signaled by the BGP from the controller. I want to point out that all these RCPT P2MP tunnel or MLDB tunnel or SRP2MP tunnel, they have identical forwarding plane. You still have per tunnel state inside the network. You have incoming label for a particular tree with the corresponding replication branches. So in the forwarding plane, nothing has changed. So it does not stick to principle number 1 of segment routing. It does use controllers here. So looking at all those options, this could be considered in the order for multicast segment routing network. If you care about efficient replication and you do not want to have per tree state inside network, and most of your replication points can do beer, then beer is the best technology, period. However, it could be that in an existing network, your existing router just cannot support beer at all because of the new forwarding plane. In that case, the traditional multicast, whether it's PIM or P2MP tunnel or even ingress replication, can still work well as long as you don't need a controller and you don't mind running those in the XR network for multicast purpose. There are some operators who say that I am using SR, I no longer use LDP or RCDP for unicast anymore. Therefore, I want to get rid of those protocols from my network entirely. I don't want to use it for multicast either. Some will insist that, some other operators could be practical, saying that I don't use RCDP or LDP for unicast anymore, but I can still use MLDP or RCDP for multicast only. That's totally fine for some operators. And then if you really need a controller to calculate trees so that the trees calculated is according to some calculation constraints, for example, bandwidth and protection, all those things. If you care about that, or if you really want to remove the legacy multicast protocols, then you can consider controller signal in multicast. I just want to point out that with controller signal multicast, we will still have per tree, per tunnel state inside the network. In other words, it does not stick to the segment routing principle number 1. And in this session, we are going to focus on controller signal P2MP tunnel. The first option of controller signal P2MP tunnel is SR-P2MP, or previously known as tree seed. It's being worked on in several IETF working groups, each focusing on different aspects of that SR-P2MP or tree seed. Basically, after the controller calculates the tree, it will signal replication segments to each tree node. Here, a replication segment is the forwarding state for a particular tree on a particular node. So that it includes the forwarding state identification, which includes tree root ID, tree ID, candidate path, and target node, which nodes on the tree this is about. And also include forwarding information like incoming label, outgoing branches and labels, things like that. The signaling for SR-P2MP from the controller can be by PSAP or BGP multicast or BGP SRTE. And in this presentation, we're going to focus on BGP multicast. The next one is MLDB tunnels signaled by BGP from controllers. Here, it's basic label forwarding, just like SR-P2MP or legacy MLDP. However, the only relevance to MLDP here is that MLDP flag is used as the tree identification in the control plane. We actually do not use the LDP signaling at all. We just use the MLDP flag to identify a tree in the control plane. The reason for that is that MLDP flag has a flexible and extensible opaque structure that can be used for many situations, very versatile. And it also allows easy transition from existing MLDP deployments. For example, you may have a BGP MVPN with MLDP provider tunnels, spans a large network, and you may want to change part of that MLDP tunnel to be set up using BGP from controllers, just in the core network. But the end-to-end tunnel is still MLDP. So MLDP tunnel signaled from BGP via BGP can be done from either from the controllers, or it still be the hop like the traditional MLDP is done hop by hop from leaves towards the roots, except that instead of MLDP label mapping, now we're using BGP message. So next, we're going to focus on BGP multicast. BGP multicast is basically that you're using this new CFI called MCAS tree CFI to signal for SRP2MP, to signal for MLDP tunnel and IP multicast, or any potential future tree types. We just use a different ROI type to identify the tree. It can be signaled from the controllers specified in this BGP multicast controller draft. It could also be signaled hop by hop from leaf to roots, specified in different draft. So the essence of BGP signaling from controllers for multicast, if you look at this picture on the right side, a BGP update message includes the NROI, and route target, and tunnel encapsulation attributes. The NLRI part will encode two things. One is that the tree identification. For different kind of trees, we will have a different NLRI route type. For example, for IP multicast, we'll encode the source address and group address. For SRP2MP, we encode the candidate path, the root ID and tree ID. And for MLDP tunnel, we will encode MLDP flag in the NROI. The NROI will also encode the targeted router. If you look at the picture on the right side, we have the controller at the lower left bottom of that picture. And in here, we have 5 routers here. The route reflector happens to be in the forwarding path itself. So if the tree is rooted at R1, and with RR being the replication points, and R2, R3, R4 are the leads, here the controller will originate 5 BGP routes. Each route is targeted at a particular router, R1, R2, R3, R4, and route reflector itself. So that's that particular router and particular route is used to set up a forwarding state on that targeted router. So NRI will encode that information. And then a route target is attached to that BGP update so that the route for R1 will only be propagated to R1 and imported by R1. The route for R3 similarly will only be propagated to the R3 and imported by R3. And finally, we have this tunnel encapsulation attribute that encodes the forwarding information. So let's take a look at the tunnel encapsulation attributes. Tunnel encapsulation attributes was initially designed for unicast purpose. It encodes a list of tunnels, which could be of different types. In unicast case, when a tunnel encapsulation attribute is attached to a unicast route, then the matching traffic will be ECMP'd or load balanced out of one of the listed tunnels. Now, if it's used for BGP multicast, then instead of ECMP or load balancing, then the matching traffic will be replicated out of all the listed tunnels in that tunnel encapsulation attribute. Here, the tunnel is quote-unquote tunnel, meaning that it's just a way to represent a replication branch, which could be that to a directly connected router, downstream router. In that case, no actual tunnel is needed, or it could be to a downstream node that is not directly connected. In that case, a real tunnel is needed. So here, a tunnel can be of a type or a new type called any encap, which means that we don't care how we get to the downstream node. It could be native forwarding if it's directly connected, or it could be MPLS tunneling or GRE tunnel or SR or P2P pass, whatever. It's just any way of getting to a downstream node is fine. A tunnel could carry some, in the tunnel encapsulation attribute could carry sub TLVs. One example is RPF sub TLV. This is basically indicating that this tunnel is used for receiving traffic from upstream. It's not for replicating traffic. If you are familiar with the PIM protocol, you remember that SG multicast forwarding state includes an incoming interface and a bunch of outgoing interfaces. Here it is similar. The RPF tunnel is the incoming interface in the PIM, and other tunnels are like outgoing interfaces in PIM. Each tunnel could include a tree label sub TLV to identify the incoming or outgoing tree label. It could also include other information for more complicated scenarios. If you look at the example on the right side, tunnel 1 is used to identify the upstream information, which means that if you receive a incoming packet with a tree label 100, then the router will know that the traffic needs to be forwarded out of 3 branches. One is the first branch is identified as tunnel 2 to 10.2.1.1 with outgoing label 100, so on and so forth. And in this case, for the third branch identified by tunnel number 4, we will use a different tree label 200 to a downstream node with address 10.4.1.1. SR-MPLS versus SR-V6. I want to point out that SR-P2MP or even MLGP P2MP, when signaled by BGP, they can work with both MPLS or SR-V6 forwarding plane. And we only need the very minimum extensions in the tunnel encapsulation attributes to use it for SR-V6 forwarding plane. I'm going to skip the details between the here about the different forwarding planes, but the slides are there. So why am I only talk about the BGP MCAS signaling in this presentation? The reason is that I believe that it is the bestest option here, better than PSAP for 2 reasons. One is that with PSAP, you need 1 PSAP session from the controller to every tree node, as shown in that lower right picture, part of the picture. In the unicast case, you need one PSAP session to every edge node, but you don't need PSAP session to transit nodes. But if you use PSAP to signal SRP to NP, then you need PSAPtions to the internal routers as well. However, with BGP, you only need one BGP session to one of the BGP speakers in the network. You can add another session for redundancy purpose, but that's all you need. In this picture, we have the one BGP session to the route reflector in the middle, and then the controller sends all the BGP routes towards that one BGP speaker, and then the BGP infrastructure will finish the rest, will get the routes to the public routers. And the other reason is that BGP multicast signaling provides great coverage and extensibilities. With the same procedure, we can use for both underlay tunnels and overlay multicast, whether it's IP multicast or SRP to NP or MLBP or any future types of multicast tree. We can even use this to replace the BGP and APN, and which will work well, very well in certain scenarios. In this presentation, we're not going to talk about BGP and APN replacement, but it is actually covered in the IETF draft I mentioned earlier. So it can also support bidirectional trees. It can be used for both hop-by-hop or controller-driven signaling. It's easily can be easily used for end-to-end inter-region support and integration with classical transport, which we'll be talking about next. So inter-region multicast, basically an end-to-end multicast tree or tunnel can span multiple regions. Here, a region is an AS or an ISP area. We can use different signaling in different regions, and the border routers, regional border routers, will be responsible for stitching them together. For signaling across a region, we can use in-band signaling, or we can use overlay signaling over a region. So in the overlay signaling case, the internal routers do not keep state for end-to-end trees. But with in-band signaling across a region, the internal routers will maintain the states for each end-to-end tree. Here are some examples. We have metro region 1 and 2 on the sides, and we have a core region. And let's say the routes are on the left side and leaves are on the right side. It could be that we have end-to-end IP multicast tree for a source group. And in the region 2, on the right side, we can use PIM signaling. And when it comes to core region, we can do MLBP in-band signaling. And then on the region 1, we can use BGP signaling. Similarly, if we have SRP P2D tunnel spanning those regions, then we can use PSAP for region 2, BGP multicast signaling for SRP to NP in the core region, but it's controller driven. And then in the metro region 1 with BGP SRT signaling, which I didn't talk about. The key idea is that different technologies can be used in different regions. One thing I want to point out that in case of hop-by-hop signaling, inside the region, the routers need to determine the reverse path for the neighbor, and that does require the routes towards the routes. And in some deployment scenarios, for example, BGP LU, the internal routers actually don't have the route to the routes, the tunnel routes. In that case, the RPF performed by the internal routers need to be towards the upstream border router instead of the root itself. And that upstream border router information can be encoded in the various protocols, whether it's a PIN or MLDP or BGP multicast. And then overlay signaling, obviously it's over a region. The internal routers do not keep state for end-to-end trees anymore. In this example, RBR2 will signal to RBR1 directly. This could be done by BGP and VPN. It could be done via MLDP over targeted sessions, and it can be done by BGP MCAST. I want to point out for MLDP over targeted session or BGP MCAST, there is actually no difference between overlay and in-band signaling. It's just whether the upstream or downstream nodes are directly connected or not. So after the RBR to RBR signaling, then the upstream RBR, which means regional border router, will tunnel traffic to the downstream RBRs. That could be either ring server replication or P2P tunnels. Okay, we can talk about multicast with class 4 transport very quickly. BGP class 4 transport is some IETF work that is led by Juniper. It basically, the underlay routes are classified into transport classes. They are advertised by a new CEFI, we call it class 4 transport CEFI, and they have attached a route transport class route target attached. Those transport route targets specify the transport class, and also it is used to control the route propagation and importation. And then the service routes will carry a mapping community. That mapping community will map to the transport class, which means that specifies which underlay routes to be used for to resolve the protocol next hop. So when it comes to multicast, multicast tunnel or multicast tree could be an underlay tunnel for a particular transport class, or it could be an overlay multicast tree that needs to use a particular underlay tunnel with a particular transport class. So either way, the BGP multicast signaling can carry a mapping community to map to the transport class, and that will affect the path or tunnel selection between upstream and downstream nodes. It could also be used to affect upstream node selection for a downstream node. So those are very high level information there. If you have want to know about more details, we can have deep dive sessions arranged. So summary, we can have various options for multicasting segment routing networks, whether they stick principle or SR principles or not. It's really up to the operator's choice. So if we're not using beer and we're not using traditional multicast technology, then BGP multicast to me is the best option. We only use a single session from the controller to one of the BGP speakers. It provides great coverage and extensibility. And if you use BGP multicast to signal MLDP, then there are additional benefits that simplifies the transition from existing MLDP deployments and the flexibility and the extensibility due to the opaque structure of the MLDP FAC. And we talk about end-to-end inter-region multicast. where different signaling methods can be used in different regions. And also, BGP multicast signaling can easily integrate with BGP class 4 transport. So that's the end of my presentation here. We have a few minutes for questions or comments.
Well, thank you very much, Jeffrey. Owing to the fact that only actually Denise in the back there can talk to Jeffrey, we will not be taking any questions. So if you have something important to relay to him, then please let one of us know, and we will do that for you. Thank you very much for that dive, and I hope everybody paid good attention for the test afterwards.
So this brings us to the last speaker of today, and that is, yes, give her a warm welcome. It's Vesna Manojlovic, and she will be talking about, well, the things that changed in the last 1.5 years, I guess, and how that affected our lives. So please take it away, Vesna.
Thank you. Hi, so also pay attention, this will be also on the test. What do we have in common? Princess Leia, Lizzo, and me. This is an illustration of me. This will be revealed throughout the presentation itself. And yeah, official talk title is Technical Community Resilience during the pandemic of the last 1.5 years. And the actual topic is all these fuzzy, sensitive human topics that are really difficult to talk about. They were hard before, and now it's extremely painful to talk about everything that has been happening, but it has to be done. I hear an echo. Is this okay, or this is fine? Okay. My name is Vesna. That's Lente in Serbian, Dutch. And I work for RIPE-NCC. So what are my qualifications to talk about mental health? Well, first of all, I will use this laser pointer to show the other illustration that I identify with, which is a goddess with 6 to 10 arms, because this is how I see myself. So I'm an engineer, I'm a mother, I am employed as a community builder, and I used to be a trainer and all kinds of other things for RIPE-NCC. I'm a hacker, and I'm also very active in the RIPE community with more and more of these social topics and tasks rather than technical. So one of my previous obsessions was diversity and inclusion. Then I became a trusted contact, or so-called confidant, for the RIPE community. And my next obsession was the ethic in technology. And then now I'm interested in mental health topics. So I don't have professional qualifications for that, but I did survive a lot of these things that you can see here in acronyms, and in a great tradition of these tech talks. I'm not going to explain what any of them mean. Well, okay. I will mention some of them. So complex PTSD, that is something that I kind of self-diagnosed, and then the doctors here in Holland were like, sure, go get some help. So I've been seeing therapists for many, many years for this, and I've been also suffering from chronic RSI, repetitive strain injury, that a lot of people that deal with computers and have a bad posture also have. And I'm also on the spectrum with a lot of these other things like OCD, ADHD, LGBT, autism spectrum. So I have some personal experiences with like a problem side of things. And for the solutions, since I'm overachiever, I tried everything. And some of the therapies were really helpful. But in the end, the COVID and the life interfered, and I ended up taking medication. This one, SNRI, or in normal people's talk, Zoloft, which together with Corona helped expand my personality and other aspects of myself. And I can recommend a lot of these to you. But it's not only about me. What I want to talk about to the techies about these topics is like, how do I do that? So I decided to actually compare it to the abstraction layers of network architecture, which is OSI model, and then to compare that to the Maslow pyramid of needs. So both have started with fewer layers than what they are depicted here on. So the Maslow had 5 and then 8 and then 9. And the OSI layers were, normally they have 7, but 2 have been added by Avi Nemeth. And so here she is. I'll get to it. So this slide is doing a lot of work, so I'm actually going to spend some time on it. And can I have a timer? Because I can stay here like forever. So you really have to tell me when to stop. Okay, so I started researching this, like how is the COVID impacting the communities, and then working from home, and what does that do to us in the March of that year. And then in the March of this year, I started writing RIPE Labs articles based on this kind of layered approach. So there are 10 of them. So the 9 for each layer, and then the 0 article, the introduction. They are all available on this URL. And so all the details and all the links are there. The presentation has no links, which is also weird for me. So yeah, I've been researching like what are other technical communities doing. So I'm going to mention them in a slide for every layer itself. And it's been taking much longer than what I thought. So I started in March, and then the last article was published 2 days ago. And so in the meantime, I have moved on from this concept of pyramid or the triangle to the symbols of a circle or a cycle that you can see here represented with the yin and yang symbol. And so the structure of the rest of the talk will be that for every layer, I'm going to mention 3 things. Moving from the triangle to the circle, which technical community or which other community has been dealing with that specific issue, and how is that relevant for you. And finally, introducing one woman who is my role model for that specific topic. So I covered the triangle circle here, and then there's RIPE community. So in March this year, there was a small group of people who was worried and concerned about these topics and thought, how do we approach that with RIPE community? So we have run a survey, and then in May at the RIPE 82, the results of that survey were presented at the RIPE meeting by Eric. He is well known here in the NLNOG community. And so that has had a very positive feedback, and so we thought, okay, this is really interesting, everybody's interested in this, and so we organized another open day, and there was about 20-30 people. We were talking about it among ourselves, came up with some tips and so on, and we will be organizing more of those. So this is what the RIPE community is doing about it. And then finally, Avi Nemeth, her connection with Holland is that this is a photo from the year 2000 when she was giving a talk at the NLNOG conference in Maastricht. And she's an author of sort of a kind of a Bible for the sysadmins, so from really long time ago. And that's why I like her. Okay. Layer 1 is a physical layer with OSI, and it is also with Maslow, like physiological needs. So what do we need to survive? And included in that is mental health. So we really need to take care of our mental health. There you have like all kinds of tips. But the main message here is that you are not the only one suffering. So that's kind of a compounding problem. So you're suffering, but then you think, oh my God, why am I like this? And nobody else is like that. And then you add shame to it. And it's really not necessary because you are not alone. So the community that has been dealing with this very well is the Irish Internet Exchange, INEX. They organized a meeting for their members and they invited a clinical psychologist to give a talk to them. And you can still see that video on YouTube. The famous person who has been struggling with mental health and has been very public about those struggles is an actress known to you from Star Wars, and her name is Carrie Fisher. Unfortunately, she died some years ago, but she was really famous for being very, very public about her own struggles. Layer 2 is a data link on one hand and the safety needs on the other hand. So the pyramid shown on the slide is like showing how to reduce risks and how to reduce harms personally and then in your environment. And the important message is that you cannot just deal with safety issues on your own because you're not safe until everybody else is safe. I'm hoping somebody's going to teach that to the Dutch government. The software developers have been also organized about their own needs and issues, and so they created a very largely popular survey and published a report, again, that you can access through my RIPE Labs links, with the advice on how does the economic safety contribute to your mental well-being, among other things. So that's why they're mentioned in this kind of safety topic. And the woman there is, somebody wants to shout? Hedy Lamarr. She is both a famous actress and an inventor, because her patent for spectrum hopping, something like that, has been used in the early Wi-Fi technology. So we have her to thank for our wonderful Wi-Fi here and everywhere. Layer 3 is the networking layer. Yeah, you're doubtful. Well, layer 3 is a networking layer, and it's also, and with Maslow, it's the need for love and belonging. And they both have to do with connection. So either connecting the hosts or connecting people with each other. And so moving from this kind of structured way of dealing with these concepts to the more rounded expression of needs and feelings. And the example here is from the nonviolent communication approach to it. The community very active with this topic used to be something called open source and feelings, and they had a lot of conferences in the previous years, like 2015-16, and their material is wonderful. So again, links are available on RIPE Labs. And the woman who is very active in this area is Brené Brown, a social scientist, researching the issues of shame and belonging, and also vulnerability, but in the psychological sense, not in the security sense. Layer 4, a tricky one, it's the transport layer and the need for esteem. So that's like, for me, what connects them is ACK, so acknowledgement. And this is what you get, not from the people who satisfy your needs for the actual love and belonging, but from like friends, colleagues, and so on. And the Arabic language has wonderful scale of these relationships that you can describe in great detail with very specific words, described here both in a triangle and in a circle. The woman here is an illustration of a lot of professionals that are sharing their knowledge on Twitter and the other social media, and that's very wonderful and supportive community for people who are a bit either shy or don't want to go to the therapist. Well, you can get kind of a therapy on Twitter if you do it right. What she is recommending is resting, restoring, recovering, so not just being focused on your work, but saying no, just like this, my favorite animal, the lowyard, is doing. And then the communities, well, I decided here to list a lot of them that might be familiar to you or that you're also part of. And in the last year and a half, they all had to go online. So they did not have meetings, but they still continued giving each other esteem and being connected to each other online. And they have produced a lot of interesting content also about these topics. Layer 5, what was it? Well, something. I'm losing track on the OSI stack, but then for Maslow, this was need for understanding, so the cognitive needs. And they're illustrated here with the pyramid of the academic achievement, like they really have to drop everything else, which is not a great thing, and moving towards more holistic understanding of the fact that we are all somewhere on the spectrum. And this is just one of the illustrations of how colorful that can look. The woman on the slide is somebody that I actually just learned about, Judy Singer. She coined the term neurodiversity. And this is very prevalent between, like, among our crowd, among the techies. There is a lot of people that are on the spectrum. At the SHA conference in 2017, there was a wonderful presentation about it, illustrated using the characters from Winnie the Pooh. And again, you can watch that online. It's really nice. My favorite. The need for beauty and for the aesthetics, and why I like this is because it also appears in the list of hackers' ethics values. So the fact that you can create art and beauty using the computers connects this Maslow layer also back to the technical community. And yeah, I found that really interesting. And on a lot of conferences, there is always some kind of presentation about how do you combine the technology and art and produce, because apparently, even as techies, we do have need for beauty. The other way to fulfill that need for beauty, except for the art, is nature. So being connected to nature, illustrated here with my cat and my plants. That's my pandemic hobby. And so that gave me a lot of resilience and warm feelings and a lot of energy to be connected with them while the world is burning. Which brings me to my second topic, and that is what do we do as internet engineers to the rest of the world. So on the picture here on the top, you can see a lot of catastrophic weather events that some people say are connected with climate change, human-induced climate change. And Radia Perlman had a great talk at the Campus Party conference where she was asking, like, are we the good guys? Can the internet contribute to the survival of the humanity and the planet, or is it actually making things worse? And I like to refer back to the presentation from the Freedom Internet, where you were pouring oil or something from the IPv4 canister. Well, yeah, that reminds me of that saying that the data is the new oil, or the internet is the new oil industry. I hope not, so I hope we are going to do something about it. And Radia Perlman, she has 100 patents, and she was working on like some of the standards for the early bridging and internet, and so she hates it, but people call her the mother of the internet. So I'm going to use it here anyway. Okay, that was most of the talk. Oh, there's still 10 minutes, great. A small intermezzo. So these layers until now were about the more like infrastructure of the internet. And now we are coming to what ordinary people actually find the internet is for, the cat pictures and memes. So we are coming to the application layer, and yeah, I just wanted to drop these memes here to troll the audience a little bit. Okay, I will explain a joke to point out that there isn't much difference between one system that is using arbitrary connections between heavenly objects to kind of control your life decisions, and the other arbitrary system that we came up with to help us deal with the complexities of networking and life. Layer 7, the application layer on one hand, and the layer of self-improvement with Maslow, so self-actualization. The point here is that while trying to work on ourselves and achieve self-actualization, it is important to notice which privileges we have and to use those powers to help others that are less privileged than we are. And while writing this article, for me, it was interesting to kind of put against each other the concept of privilege in security and technology, like the levels of access that you have or you prevent others from having, with the privileges in social sciences and the researchers of inequalities and so on. So yeah, these weird things I find interesting. And the woman who is an inspiration here, Lizzo, she's an American singer, and she's been also quite public about her mental health struggles, and also an advocate for body positivity. So in my new pandemic size, I really like her, and I like to take inspiration from her. The community that has been very active were also the digital rights activists. They also had their own survey and produced a beautiful report, which you can see here, and it's really worth reading, and we'll come back to them when, later in the presentation, because they are organizing more events, and if you're interested, you can take part in that. So, the even more made-up layers than the previous ones. The layer 8, the financial layer when it comes to modified OSI stack, or the contribution layer when it comes to Maslow's modified by the First Nations perspective, because that's also like something that has been happening. To move from this individualistic way of looking at things to more like communal. And so it's the need for community contribution as opposed to the financial contribution and profits and so on. So this is also connecting back to the presentation from the Freedom Internet. So it's not all about the money, it's about the feeling of belonging, feeling that it is worth because of your personal values and social values to contribute to somebody's internet service provider or to somebody's well-being in some other way. So moving from the pyramid symbol, here describing how the internet is right now. So far away from the idealism that we were feeling 20 years ago when we thought, oh, internet is going to bring equality to the world. Well, actually there is now a lot of consolidation, and internet is kind of controlled with multinational corporations. So to get rid of that kind of hierarchy, there are a lot of alternative economic systems being suggested. For example, donut economics by Kate here. And Amsterdam, the city of Amsterdam, is also working on implementing some of those elements of circular economy in our communities, in our life. And then on the other hand, there is a gift economy, which is practiced a lot by the nonviolent communication community. And again, I recommend them to you if you're looking for some new way to contribute and to have being contributed to. We don't even have words for this. So the last layer is the political layer when it comes to OSI and the internet governance. And when it comes to Maslow, it's either transcendence or cultural perpetuity. I love those complex words from social sciences. So here is like the moving away from this hierarchical way of thinking of development, like top-down development as the sustainability development goals suggest, towards more, again, round way of relating to each other, which is symbolized in the Ubuntu expression. So not the Ubuntu operating system, but the philosophical concept of Ubuntu, which means it is the society that brings out the best in humans and makes them human, rather than this individualistic self-actualization. So that's why I love this circle of Ubuntu. The community that has been very active on the political layer and also thinking about the well-being of the future generations is the Extinction Rebellion. And the role model for me on this level is a Dutch politician. I always confuse her name, Sylvana Simons. She's been really fighting in the parliament for the rights of the less privileged people, and I appreciate that. And she's super eloquent and courageous and really irritating to these other politicians. So I love that. And then a bonus woman, Ursula Legwin, she writes about these ideal utopistic societies in her science fiction novels. And so this is how we can imagine how else our society and our politics can be. Whoa, I said it's the final layer, but there's a lot more slides, and there's only 2 minutes left. So this kind of little meme which says, oh, but under all those fundamental layers, there's actually the most fundamental need, which is having Wi-Fi. Well, there is no Wi-Fi unless we have a living planet. So the Extinction Rebellion is saying the world is on fire, and it would be good if we take our great powers and turn them into great responsibilities as techies to make sure that there will be a world for us and for the future generations to have the Wi-Fi on. Because our decisions are never only technical decisions, our decisions are also political. What can you do? Well, you can ask for help if you need it, or you can offer help to somebody else. There are, again, therapists, there are online groups, And there is this village being organized about sustainable networks by the digital rights activists. There is the NLNOG IRC coffee, where you can actually chat with people about other topics. And if you want to do it in a bit more international setting, you can join the diversity task force at the RIPE community. So, the answer to the riddle from the beginning, what do we have in common? Well, we are all three very publicly and proudly resilient towards the mental health struggles that we have encountered and are still going through, except for Carrie Fisher, who died. But Lizzo and me, we're still fighting. And we are, very active in our community too. And so, final slide is more cats. Thank you very much. And now, wait, no applause. I want to ask you for something else. So, what I want to ask you to do is to get up and join me in 1 minute of silence. Go on. So that we can all mourn everything that has been lost in the last year and a half. So a lot of lives and health and friends and family that we have lost, and a lot of fun that didn't happen, and a lot of connections. So let's be silent for 1 minute. Thank you.
Are there any questions for Vesna? I'm checking meanwhile if there are any online questions. But there are not any questions here. No, it doesn't seem to be. In that case, thank you very much, Vesna. And that brings us to the closing ceremony. So, here is Nathalie.
I could use a beer after this. All right. That was NLNOG Day 2021, but not just yet. I'm standing between you and food and beers, so I'm going to make this quick. I'm going to have to thank a few people and a few companies. First and foremost, I want to thank all the speakers today, remote and on-site. Thank you very much for your time. It's never easy to approach people to ask for a talk and get them on a stage. But yeah, I think every speaker did great today. Then the sponsors. Yep, you know it. We can't do this without them. Next year, we're going to have our 20th anniversary. So if you think your organization might be willing to sponsor us, get in touch. And hopefully, as of January, we can have your organization as a sponsor as well. For now, I would like to thank LoanApp, Duocast, Quansa, RIPE NCC, M6, Solid Optics, KPN, Juniper Networks, Power DNS, Internet Society, OpenBSD Amsterdam, NLIX, Arista, SpeedIX, NLNet Labs, and i3DNet. Thank you very much. Then, there is a crew that you don't see during the day. And they're behind that curtain over there. And they will remain anonymous. But they are called Sven and Denise, and they are from Global Media Productions. Thank you. You might have noticed that we have Wi-Fi on the NLNOG SSID. And we have IPv6 in Podium Mosaic, yes. And we have RPKI route origin validation as well. So I want to thank Event Infra for taking care of that. Thank you. Then the shining light that's also behind the scenes, that makes these banners, the intermission slides, basically the t-shirts, makes us look good, the badges. We can't do all of that without Anna from the Red Dress Effect. Thank you, Anna. Then, last but certainly not least, we wouldn't do all this without you, the attendees, participants, people here, people who traveled from abroad even this time, yeah, in these times, and the people who have watched the stream. So thank you very much for coming, and I hope you enjoyed it. Right, about food. It works the same way, kind of, sort of, as the lunch. So we divide the room in two again. There are 2 stairs. There's food on either side. But this time, it's a buffet. So there will be staff standing behind the table, so you can say a little bit more of this and a bit less of that. So that's good. And we opened the back doors. It's really sunny outside. It warmed up. So if you want to sit outside on the terrace, you can now walk that way around or that way around. Yeah. Dietary requirements. If you notified us of your dietary requirements, please go to the bar, state your name. They have food ready for you there. And the staff asked us that if you finish your food, please take your plate to one of the waste collection points that they have, to just empty your dish and pile the plates so they can take them inside, so that during the drinks, we're not sitting in piles of plates. I think that's it. Did I forget anything? I'm looking at my lovely colleagues.
Ordering drinks via the app again.
Yeah, ordering drinks via the app if you're outside. Then the staff will bring it to you outside. If you're sitting inside, you can go to the bar. I think that's it. Enjoy tonight.